Hi, good morning, everybody. Can you hear me? If you can hear and if you can see, just say good morning in the chat, and then we're going to begin shortly. All right, so I'm seeing everybody saying good morning. Just a heads up, we're going to be focusing on two questions today in the morning session. That will be question number 9 and question number 10. So before we begin, I'm just going to highlight the areas that we should remember or should be using a lot for the morning session. So if you have your notebook, you should have your notebook close by. All I'm going to be doing today is past papers only. Are we going through? So some things you may be seeing for the first time, some things you may know, some things you forgot. So we're going to be learning and practicing through past papers. No problem, no problem. All right, you need your calculators. You need your book to also write down any, like a summary sheet of all the things that we're going to be doing. So for those persons who are here, let me just quickly write down what we're going to start off with. We're starting off with question number 9. And question number 9 is advanced geometry. Now, the reason I'm doing 9 and 10 this morning is because these are the questions that students tend to not answer or answer poorly. So I wanted to spend some time at least trying to see if we could strengthen your understanding, make you feel a little bit more confident. So when it comes to advanced geometry, these are the topics that we're going to be touching on. The first one is circle theorem. So you should know your laws. You need the laws in order to answer this question. You must know the laws. There's no way around this. So if you do not know the laws at this moment, I'm going to show you a quick summary sheet of the laws, and you have to ensure that you spend some time memorizing them, okay? Then after circle theorem, we're going to have trigonometry. Trigonometry is broken down into 2 because trigonometry deals with triangles. That's the only thing you're going to be dealing with, triangles. But the thing is about these triangles, guys, is that they don't just give you a regular triangle and ask you to find the missing angle or the missing side. They're going to give you real world situations, and you have to be able to draw your own triangle if they don't give it to you and answer the question. So there's 2 types of triangles we're going to be dealing with. Can anybody name this triangle that I'm drawing at the moment? What do we call that type of triangle? So that's triangle 1, and then I'm drawing triangle 2. So anybody, what is the name of triangle 1? Hello, guys, can you hear me? And this is my thing, right? If you do not know, we have 17 people in here, communication, you know, that's the only thing I ask for, right? If you don't know, you need to say not sure, or you need to respond, okay? So everybody shake out how you're feeling. Let's jump into our session. Let's get ready. Excellent. So this is what we call a right angle triangle. What makes it a right angle triangle? This little box here tells us that the angle in this triangle is 90 degrees. That's what it means. So anytime you see that box in geometry is 90 degrees. So we got the right angle triangle, and we have a regular triangle, which is any triangle that is not a right angle triangle. So I'm going to break down the rules that you need to know. And I'm just going to quickly ask if you remember them before we start. So when it comes to the right angle triangle, this is what you should remember. The first law that you should know is Pythagoras theorem. And the formula for that is C squared is equal to A squared plus B squared. Or a more direct version of the same formula is C is equal to the square root of A squared plus B squared. So I'm just going to quickly explain when you use this. So when you have a right angle triangle, right? And they give you two sides. So you know these are the three sides of the triangle. You should know the name of this specific line. This is called the hypotenuse. Right? And this is what we call C. And the other two lines are just A and B. Okay? So anytime they give you two out of the three, you should be able to find the missing side using Pythagoras theorem. Please note that this has nothing to do with angles. So if they give you sides and they ask you for sides, you use Pythagoras. If you got it, say got it. So let me know if you all remember this. If you learned it, just let me know if you remember. So just give me some quick feedback about Pythagoras. No, if you don't know Pythagoras, I can't teach in the details today because of our specific goal. So if you know you don't know this, you need to write down this in your book. I sent everybody a textbook. I'm going to send you again. So you could always go to the textbook and look at it, okay? So this is just Pythagoras. You're using Pythagoras when you're looking for a missing side of a right angle triangle when they give you two out of the three. And next rule you need to know when it comes to Pythagoras is trig ratios. Right? Anybody know the trig ratios? There are three of them. What's the three trig ratios? Sine theta, cos theta, and tan theta. Right? And you should memorize them. All of them are fractions. And all of them use the different sides of the triangle. So let me just quickly draw the triangle on this side. So all triangles have three sides and they are all labeled based on the location of an angle. So let's say theta. So this symbol here, guys, means angle, right? So if this is where they put the angle, everybody see the three sides? Now, which one don't change? This line don't change. The side that is opposite the 90 degrees is always called the hypotenuse, and we call that hype for short. Now, we got the two other sides to label. If this is where our angle is, right? This angle is opposite to this side. Everybody agree, right? So that's why we will call this opposite, because it is opposite the angle. Then this side below here, anybody realize that this side is next to the angle, it's touching the angle? So this side we call the adjacent. So what's the three sides we have? Hypotenuse, which doesn't change, which is the longest side, opposite the 90 degree. We have the opposite side, which is always opposite the angle. And we have the adjacent, which is always next to the angle. So let's quickly go through the formulas for sine. For sine and cos, an easy way to remember is that their denominators are the same, and the denominators for sine and cos is always hype. Now, guys, this formula is on the exam, so if you don't remember, you could always go to the front of your exam booklet and you find these formulas, okay? All right, so sine, gonna always use opposite, adjacent, cos gonna use adjacent. So what's the formula for sine theta? Opposite over adjacent. What's the formula for cos theta? Adjacent over hypotenuse. And the last one, tan, is just simply up over edge. So these are the formulas you should know by now. If you know you don't know them, please take notes. Now, these two formulas you're going to use in different ways. You're going to use it with angles of elevation and depression. This is where the real questions is coming. So I have a question for everybody. Have you learned angles of elevation and depression yet? If it's yes, say yes. If it's no, say no. I just need to know what everybody knows. Angles of elevation, even if you ain't really get it 100%, if you learn it, just say yes or no. Okay. All right. I'm waiting for everybody else. So guys, all of these topics here deal specifically with what type of triangle? The right angle triangle. So when you see a right angle triangle, the first thing should come to your mind is that you're either going to use Pythagoras, trig ratios. These are the two sets of rules you're going to use under these conditions. All right. So when it comes now to the regular triangle, there are two rules that you're going to use, which is called the sine rule. And this, luckily for us guys, all of these formulas on the exam paper. So it's good to memorize them. If you're aiming for a 1, you should memorize them. I think everybody should try to memorize them, but don't stress yourself too much because it's on the exam paper. So you could always flip and look at it and write it down, okay? The sine rule is simply it's a little glitching. A over sine A is equal to B over sine B, which is equal to C over sine C. There's two things you need to know. Where we get A, B, and C from. So I'm just going to draw a quick triangle to make sure you understand how to find the different sides. Right? All right, so let's check it out. Now, we use capital letters to represent angles, right? So if we look here, if I say this is point A, this is angle A located here. Everybody with me? So if this is B, I know right here is called what? Angle B. And if this is C, this is called angle C. So if you got it, say got it. I just want to make sure we understand these things. So points and angles are represented by capital letters. Let's go talk to me, talk to me. Now, common letters, I'm still watching the chat, eh? Common letters are represented by sides. So, and it's always the opposite. So if this is angle A, what side is this here, guys? Let me see who's paying attention or who knows already. What would I call this? Excellent. This would be side A, small a, right? What would over here be? Small b, very good. And here would be small c. So don't forget, the angle is always opposite of the side. So capital A is the angle and small a is the side. So when you're answering these questions, it really comes down to making sure you do the correct substitution. Now I want to test something. Everybody get your calculators in your hand. When you have your calculators in your hand, say ready. I need to make sure your calculator is giving you the right values when you're dealing with the functions. Look on your calculator, make sure you find sine, cos, and tan. Everybody see sine, cos, and tan? Above sine, cos, and tan, you should see sine inverse, cos inverse, tan inverse. So I want you to plug in this for me and tell me what my answer you get. Everybody put in sine 60. Put sine 60, type this in your calculator. Sine 60. Tell me what number you get. I'm looking. It is always good to use 3 DPs, guys. When I say 3 DPs, what I mean, 3 decimal places, okay? It gives you a more accurate answer. So you know you have to do some rounding off, right? So what you should get, sine 60, you should get a decimal 0.866. Make sure if you don't have that, check your calculator. I mean, your calculator needs fixing. No, I need everybody to put cos 60. Tell me where you get, because we're going to start the questions now. Cos 60. Tell me what answer you get. Very good. We're looking good. We're looking good. Excellent. Now, tan 60 to 3 dps. I want 3 dps, which means 3 decimal places. You should know how to round off, eh? Remember, 3 decimal places mean you have to make sure you have 3 digits in the decimal place. So come, I'm waiting for everybody to send your answers. Excellent. 1.732. Now, do you know that these functions change these angles into a length representative? So these digits is the first step of changing an angle to a length of a side. So let's do the opposite. I want everybody to find sine inverse 0.5. So everybody type that in, sine inverse 0.5. You should know how to do that. Some people you have to press shift. Some people have second. Please make sure you get 30. It's supposed to be 30 exact. And your answer is going to be a degrees because you're changing a length back into a degree or angle. Everybody getting it? I've seen a lot of people not sending this one. Make sure you get 30, please. Excellent. Excellent. I want you to do now tan inverse 1. Tan inverse 1. Tell me how much you get. Excellent. So that means your calculators, once you got these figures, your calculator set and it's good to go. Okay. Make sure what you're using now to practice, you use in the exam. Okay. Now, the topics that are going to come under this regular triangle will be bearings. And to be honest, bearings ain't as hard as people think. Eh? Yeah, bearings ain't that hard. So bearings is where we're going to use this topic when it comes to the sine rule. And the last rule that we need to look at is the cosine rule, which comes on the exam as well. The formula comes on the exam. A square is equal to B square plus C square minus, hold on there, I'm looking for my formula sheet. Like this formula, even me, sometimes I forget the second part. But we're gonna get to that too soon. Hold on. One minute, please. I just want to make sure I give you the right thing. It's 2BC, right? I have it here. Yes, 2BC cos. To BC cos A. All right. So for those persons who never see this before, don't panic. Remember, to pass, your job is to try to get as much marks as possible. So even if you don't understand every single thing, try to pick up on something so you could get marks. Everybody see what I'm saying? Sometimes when you just put the right formula and you substitute correctly, you get marks. When you get your answer, you get another mark. So don't feel stressed, don't feel overwhelmed. So this is what we're going to spend the first hour on. What time it is now? Let's see, because I want somebody to keep track for me. As soon as they reach 10 o'clock, somebody let me know when it reached 10 o'clock so that we could make sure we're managing our time properly. But I am ready to start. So if you're ready to start, say ready. Let's get it going. I'm just going to take a quick register here for those to see who are in class. Okay. All right, guys, let's go, let's go, let's go. We got this. Now, what I'm going to do, these is the more needed necessary theorems for circle theorem, okay? So there are 8 of them. So my first question to you is, before I even go through them, how many do you know? So I need everybody to type and tell me how much do you know out of the 8. How much you know, how much you remember? Okay, I'm getting some feedback. So most persons saying 5, a lot of people saying 5. Okay, 5 out of the 8. Okay, all of them. You know all, but you only understand 6. Okay, which one is 6? Okay, got you. Come on, everybody, talk to me, talk to me. I need to know what we're working with. And then we're going to jump straight into them. 6 of them, okay. All right, now, I'm going to tell you now, circle theorem is like a puzzle, right? When you're putting a puzzle together, what's the first thing you must do? And look at all the different pieces. And when you're trying to put the puzzle together, you start looking at which ones match, which ones need another piece, and you put those together so that you get your final product, which is the completed puzzle. So one of the things you need to make up your mind is that you have to look, you have to search, you have to look to see if you find the different theorems to help you find the missing angles. All right, so we have some matching to do. So we got 1, 2, 3, 4, 5, 6, 7, 8, and we got A to H. I want you to look at it and tell me, which one should I label number 1? So read through. Let's see if you know which one you should be labeling A, number 1. There's a symbol in this picture that should kind of give you a hint. Anybody know the symbol we're talking about here in the first picture? What's the symbol that you should be looking at and paying attention to? This symbol here. What does this symbol mean? What angle is that specifically? What a box mean? Remember we spoke about that? A box have a meaning. That box is a right angle. So if it's a right angle, how much is that? 90 degrees, right? Excellent. So the first thing we need to remember is that whenever you see this line, anybody know the name of this line here? It going to the center of the circle, touching the other side. This line is called the diameter. So what they're saying is that any angle that is formed on the diameter, because if you look at it, that's the diameter. Look at the angle that's being formed on the diameter, and it touches the circumference. That angle is always 90 degrees. Okay, that's all. Everybody got that one? That's easy. So this is the 90-degree diameter rule. And the law is the angle in a semicircle. That's the rule. You must remember the rule. You know why? If you don't remember the rule, when they ask you, they're going to always ask you, why is that the answer? You have to give the rule. So if they want to know why this is 90, you're going to say the angle in a semicircle is 90 degrees. So number 1 is G. All right, number 2. Anybody know number 2? I'm just going to quickly go through it because for the interest of time. These two angles are formed on the same chord. Look at it. Both of them have the same start and ending position. So they start at B and they end at C. Everybody seen it? Anytime two angles start and end at the same space or on the same chord, they are going to be equal. So if here is 20, that means over here is 20. If here is 40, that means over here is 40. I like to call this the twin angles. So when you hear me say, look for the twin angles, that's what you're supposed to be looking for. Now, what is the official theorem? Angles that are on the same segments are equal. Anybody see that one? Cheyenne said C. That is correct. C is for number 2. Angles in the same segment are equal. Or you could say chord. You don't have to say segment. You could say angles on the same chord is equal. All right, let's look at number 3. Anybody know what type of triangle is this? You should know all the triangles, huh? You should know the equilateral, the right angle, the scalene, the isosceles, right? Which one is this one? Okay, I see some people trying. These 2 lines mean something. Anybody know what these 2 lines mean? They mean that those 2 lines are equal. So which triangle has 2 equal sides? The isosceles triangle, okay? This is an isosceles triangle. It means then that 2 of these angles are matching as well. So which 2 angles matching? The angles at the base of the 2 equal sides. So these 2 angles here match. So if here is 20, here is 20. If here's 40, here's 40. So this answer would be what? So we don't use, let's scratch out the ones we use. We don't use G. We don't use C. So this one must be D. Everybody see that? I like when people say, oh, you know, I hope y'all seeing what I'm showing y'all. You have to look for these elements. Look for the lines, look for the different triangles. That's what you're looking for. All right, number 4 is easy. Same thing that we saw before. Both angles are drawn from the same starting point and ending point. But what is the difference here? Anybody could tell the difference? One gone to the center and one gone all the way up to the circumference. So which rule is this one? And if you look at what it's saying 2x and x. That means that if up here is 10, that means down here is 2 times 10, which is 20. So which law is that? Excellent, H. The angles at the center is twice the angles at the circumference. This is an easy one to remember, H. So we're cooking on gas so far. So let's do a quick check. 4 out of 4, 3 out of 4, 2 out of 4, 0 out of 4. How much do you understand with the first 4? Let me know if you understand, if you're following. This one is the diameter. Once you got angle on the diameter is 90. This one is the twin angles. Once they have the same ending and starting point, touching the circumference, they're equal. This one is the isosceles triangle. So it means that the 2 sides are equal and these 2 angles are equal. And then this one is angles at the center is twice angles at the circumference. Okay, I like what I'm seeing so far. We're cooking on gas. Okay, so let's move into the next 4. It says, y'all hearing me, right? Okay, cool. So number 5, what type of shape is this? This is called a what? A quadrilateral, right? Any shape with 4 sides is called a quadrilateral. And you realize which sides they're highlighting? They're highlighting the opposite sides, right? And there's a rule that talks about the angles that opposite each other in a cyclic quadrilateral. So which one you think this one is? This one is E. So what they're saying is that these 2 add up to what? 180. Anybody know another word for add up to 180? There's a word to describe that, you know. The word to describe that is supplementary. So if something add up to 180, it's called supplementary. So this one is E. That's easy. Now this one is the one that has given people the most trouble. This here is what we call internal and the external angles of the triangle. Anybody know what this line called out here? Before we begin, this have a special name. What is the name of that line that kisses the circle right on the edge? Excellent. Tangent. That's a very important line in this topic. You must be able to know the tangent. So which one you think this one is? Be careful because it got more than it got more than one talking about tangents. A, B, and F talking about tangents. So which one you think it is? Look at it. Critical thinking, let's go. It is going to be F. Look at what it says. The angle between a chord, and you should know that this is your chord here, and your tangent, so this is your tangent here. So the angle they're talking about is this angle here. So what they're saying is that this angle is equal to the angle. I don't like this rule. I usually give my students the shorter version to this. And the shorter version of this is the external angle is equal to the internal opposite. So what do I mean by that? What side is this angle out here on? The left or the right? Everybody, let's go. What side is the angle outside is? Where is it? On the left or the right? Excellent, right? So that means This is the external angle is on the right. So that means this is going to be equal to the internal opposite. What's opposite of right? Left. So which letter is that? That means it's going to be equal to the C. Everybody see that? And the same thing could happen on the opposite side. So let me zoom in a little bit. So you have two external angles. Look at it. Isn't there another external angle? Isn't this another external angle here? What would this one be equal to? Which letter would this one be equal to? Excellent. This would be equal to A. Excellent. All right. So that's the answer for that one. We're almost done because we're going straight into the exam practice as soon as we finish this. So this would be F. No, talk to me. What is 7? 7 is easy. Which one would be 7? So let's scratch out F. It's between A and B. Which one do you choose? Yeah. Simple, right? If you have two tangents, please note that even though these tangents ain't coming all the way out on the other side, it's still a tangent. It's still kissing the circle right here. So they're saying that if you have two tangents that meet at a point, any point, the length of those two tangents would be equal. So this would be A, right? And the last one, but one of the most important ones, let me ask this question. What do we call this line here? From the center to the circumference. What is that? Excellent. Excellent. Very good, everybody. And what do we call this one? Excellent. Everybody agree? That's the tangent outside there. So what they're saying is, right, guys, anytime a radius and a tangent meet at a point, they're going to always form a 90 degree. Okay? So that means you have B, the angle between a tangent and a radius is 90 degrees. So that's B. All right, time for us to get straight into the exam questions. So we're going to start with question number 9. Yeah, 9. All right, so how I'm going to do this, we're going to learn from the past papers. Okay? So the first one we're going to do, we can just read questions, look at the answers to make sure we understand how to start answering questions. Okay, so if you're ready, say ready, let's get started. I need your calculators in your hand. Okay, take a deep breath. We're gonna move through. If you want me to repeat something or explain further, you just let me know, okay? Now, the answer sheets that we use in have the answers and the notes. So we're gonna look at that and make sure we understand. So as soon as we finish one, all you're gonna tell me is you got it or don't got it. Okay, so let's look. Before you even answer the questions, one of the things I want you to do so that you don't get overwhelmed is look at what you have. Anybody could tell me the names of the lines? Anybody seen here? What do you see? Do you see a chord, a radius, a tangent, a triangle? Talk to me. What do you see? Anybody see the tangent? Excellent. Okay, so I see tangent. What's the name of the tangent? Let me make sure we're on the same place. Everybody, what's the name of the tangent? You usually name a line using the letters at the end points. So the tangent, the overall tangent is called TV. Everybody see that? So this is our tangent line. Very good. I saw somebody say radius. What's the name of the radius? Because I see 2 radius. What's the name of the 2 radius? Usually the center is called 0. So what's the name of the radius? So you have WO or OW, same thing, okay? Right? And then you have OU. Oh, you have a literal diameter. Excellent. Everybody see that? So don't we have a triangle that form on the diameter? Anybody remember which law that was? That was law number 1. So what does that mean? This angle is a specific angle. What angle is supposed to be? Excellent, 90 degrees. You see, even before we're going to do anything, we know the rules. We see the rules already. Everybody seen it? Make sure y'all seen it, eh? This was rule number 1. Now, another thing is there's a type of triangle. Everybody seen the triangle? Do you see the triangle inside the circle? Hello? Oh. What type of triangle is that? Excellent. Everybody see what is the isosceles? What tells us it's the isosceles? This here, boom. Now, anybody seen the external angle? Do you see the external angle? What letter is the external angle? Yup, Z. Anybody remember the rule about the external angle? It is equal to the internal opposite. So if this is outside right, inside left, that means here also means Z as well. Everybody see that? So we already see all of the different laws before we even answer the question. Now, my next question is, what is the sum of the angles in a triangle? When I add up all the angles in a triangle, so if I add up this angle here, this angle here, this angle here, all 3 of them must add up to 1. Excellent. That's a very important note. So triangles add up to 180. And what does quadrilaterals add up to? So all triangles add up to 180. And all quadrilaterals add up to 360. Okay? That's something you have to know in the back of your head. All right. Do you think we have what we need to answer this question? So let's see. The first question, and this was January. Let me just make sure y'all know what year this was. This was January 2023. So this was the January of this year. That's the paper we're doing right now. So let's read the first question. Using appropriate theorems, and you know what I mean by theorems, right? And I think what I'm going to do is just copy, bring it over with us. I'm just going to bring it over so that we don't have to be skipping through. We have it right there to use. So let me see something here. So that way, when I ask, we don't have to be saying, oh, we don't remember which one it is. We have it right where we need it. So let me just screen grab this. Then, yeah, hold on. All right, so we have this to reference now, okay? So at least if you don't remember, we could always go back and look at it. All right. So let's get back here. So it says, use an appropriate theorem, state 3 reasons that explain why the measure of angle Z is 45. So this is the first time they ever did this. They gave you the answer. They say in here is 45. Give 3 different reasons why it's 45. So let's look at this together. We're going to go through the notes. So the first one we're going to use is, we know that up here was 90 degrees. Everybody remember that? Remember we said that? Angles in a semicircle is a right angle. So they know that here's 90. Now, because this is an isosceles triangle, we know that these 2 angles must be equal. So the first thing you're going to say is 180. Take away this 90 here. And when you do that, you're going to get 90 degrees. And because these 2 angles are equal, you must divide that 90 degrees into 2. That's why you're going to get 45 degrees for these 2 angles here. So let's stop right here. Everybody with me so far? This ain't exist yet. This ain't here yet. We ain't talking about that part yet. So everybody understand why these 2 internal angles are 45? So far, we know that here's 90, and here is 45, and here's 45. Now, how can we use this information to find Z? You could use different ways. Y'all ready to see the different ways? We're going to go through all 3 one time. The first way, no problem, love, is anybody see the radius and the tangent? Look for the radius and the tangent for me. This ain't the radius here. This is the tangent here. What's the rule about the radius and the tangent? What did they tell us about the radius and the tangent? What angle is always formed there? 90, right or wrong? So if this entire thing here is 90, and they're telling you that from here to here is 45, how do you find the extra piece? Ain said 90 minus 45. Talk to me. That makes sense, which is 45. So let's look at it here. Reason number one, look at it right here. Each angle base is half of 180 minus 90, which is what we did right here, half of that. So we know that the angle made by a tangent to a circle and a chord at the point is equal to 90. So that's how we get our one there. Actually, this is the one here. Tangent and a radius is 90, so you subtract to find it. Now, anybody see another rule that we could use? What about the internal and external opposite angles? Remember we said that? So if in here is 45, these two angles, this is the external and this is the internal. So if the internal opposite is 45, the external is 45. So before we continue, everybody understand those two reasons? The first one, we use the 90 degrees from the radius and the tangent, and then we subtract. The second one, we use the internal and the external opposite. So let me just show you which two we use so far. We use this one just now, and we use this one for the second reason. Yeah? Okay. Now we're moving on to the third reason. The third reason said that the angle made by a tangent and a radius at a point is equal to, what they're saying is that, let's look at it. TUV is a straight line, TUW equal 90 degrees. So what is TUW? TUW. So what they're saying is that over here is 90 degrees. Agreed? We know that in here is 45. And we should know that all angles on a straight line add up to what? So all the angles on a straight line should add up to what? 180 degrees, right? So what they're saying is if you add this 90, you add to this 45, which is in here, you to get out here, just say 180 minus 90 plus 45. See? They use the straight line rule. So everybody got it? So the three rules, 1, 2, 3. Out of the 3, how much you understand? And then we're moving on, because guess what? That's it. Look out to all 3, how much you understand? All of these are just the rules. Excellent, guys, excellent. Now, this was the first time CXC ever did this, eh? They usually give you 1 circle theorem. This year, they gave us 2. All right, let's look at this. Anybody seen any rules? Let's look at all the rules we're seeing. Does anybody see the twin angles? Do you see the twin angles? So before I highlight them, I need you to tell me if you're seeing them, because you got to find the rules before. So this is what I just do. Even before they ask me, I just say, I know this angle because I don't see this. Look at the twin rules. If here is 56, that means here is what? These are the twins. Everybody see that? So that means X is what? Talk the things, type your answer. What is X? You have to tell me that you know what you're doing. Everybody see why is X? Because you remember this law. Let's go back again. Angles on the same segment or angles on the same chord is the same thing. Number 2, twin angles. All right. So that means here, look at it. Look at it. The same thing we just talked about. Both of them is 56. Everybody see how easy that was? No, anytime you find a missing angle, put it in your picture in the exam, on your paper. So in your exam, you take a pencil and you're writing 56. Let me use red so you can see better. 56. No, this a bit tricky. They ask us to find who next. They want us to find Y. but me want you to see the answer yet. Anybody could figure out how we gonna find Y? Look at where Y is. It's in a weird position, isn't it? Talk to me. Everybody seen it? If you know what to do, say kinda, yes, no. Tell me the truth. Do you have an idea of how to find Y? I like the honesty. Okay. So let's go over here and break it down. Okay. That's why we're here. So look at what they say. We have that already. Angle Y. First of all, do you realize on the opposite sides, there are also twin angles? Look at the 19. So even before you look at this, they're saying twin angles on the opposite side too. You got to look here. You see where you got to open your eyes? These two ain't twin angles as well. They start and end at the same place. Everybody seeing it now? So it means then that if here is 19, here is also 19. Please note, you got to twist your paper upside down, flip it, move your head to the side, look for all the rules that you see. So everybody agree with that? Now from here, let me ask this question. Anybody know this rule? What is the rule where you have two lines intersecting? These are the basic algebra. What is here called? It starts with a V. So if I have an angle A, an angle B, an angle C, an angle D, there's a rule that applies to what happens when two lines intersect and four angles are formed. Anybody know? Excellent. Vertically opposite angles. I need you to say yes or no if you've heard this before, even if you don't remember it right now. Do you remember hearing it before? Vertically opposite angles. What vertically opposite angles mean is whenever two lines intersect, and you know what intersect means, right? They cross, you get four angles. And what happens is that the angles that face each other are equal. So that means A is equal to C, isn't it? And B, so A is equal to C, and B is equal to D. Everybody see that? Talk to me. No, there's another rule inside this rule as well. What A and B gonna add up to? Let me see who thinking. A and B supposed to add up to something. What A and B gonna add up to? We're looking at this picture here still. It's 180. How do we know it's 180? Isn't this a straight line? A and B ain't on a straight line. You see all these things you got to remember? A and B is on a straight line. Look at it. And angles on a straight line add up to what? 180 degrees. So before we go back to the picture now, let me know if you understand vertically opposite. And what do we call angles that add up to 180? In supplementary. Supplementary. So if you got these two basic rules, say got it. Because if you don't got it, we can't move on. Waiting, I'm waiting, I'm waiting. All right, let me see if you are thinking now. First question, does anybody see the vertically opposite angles? Inside the picture here? Look at the picture. I don't want to show you everything, spoon feed you everything. I want you to look. Do you see the vertically opposite angles here? Do you see where they intersect and you find the X? Do you see the X? Look for the X. Who is right inside the X? Y ain't inside the X? Everybody seen it? No. Look around. What could give you some information to help you get Y? Look at this. Y ain't on a straight line with this angle here, inside here, this in the triangle. Let's call this P. P and Y ain't on a straight line. So if I find P, isn't it possible to find Y? Is there a way to find P? Let me see who's thinking. Look at where P is. Look at where P is located. P ain't inside the triangle. And the triangle ain't got two angles and P is the only one missing. So how do you find a missing angle in a triangle? It is 180 because all of them add up to 180, right and wrong? Minus, you add the two of them that they give you. What is the two of them that they give you? 56 plus 19. No, follow me still. Everybody see what I'm talking about now? Let's look, zoom in. Look at the triangle here. These are the three angles in this triangle here. So to find P, I add up these two and I subtract. So talk to me. So it's 180 minus what? 180 minus what? 75? So that means P is equal to, I'm not calculating, not a thing. Amy, seeing them in the exam, I lay now, I don't know. Anything I need calculating, that's why I say everybody should got a calculator in their hand. What is 180 minus 75? Good. Now, let me ask this question. Is this my answer? Did they ask me for this angle over here? No. This is just to help me find this angle, Y. So if this is 105, how do I find Y? Subtract, excellent. Subtract from what? A 180, because a straight line add up to what? 180. So you're gonna say Y is equal to 180 minus 105. So your answer is 75. Y'all see that battery notifying the laptop for today. So if I sign out, just give me a second. Bring my here because I thought it was charging all along. Apparently it was not. So in the meantime, guys, talk to me. You see how we have to work that question out? Sometimes you have to find something else in order to get the thing that you actually want. I call this indirect question. An indirect question means that you have to find something else first and then find the thing that you need. Everybody with me? If you're with me, say with me. With you. So you see, we got 75. All right, guess what? We're done with January 2022 with the circle theorem question. Now we're going into the trigonometry part. Take a deep breath. Woo. So when you look at these triangles, do we see any right angle triangles? Yes or no? So that's the first question you must always ask yourself. Do you see any right angle triangles? And we need to move a little faster. No, you see the normal triangles in it. So that means which two rules you think you're going to be using? You're going to be using either the sine rule or the cosine rule. Everybody with me? If it was the right angle triangle, what would we be using instead? We would have been using either Pythagoras or what? Trig ratios. Agree or disagree? Then how we had separated them. Let's make sure we're on the same page, guys. Where did I put that information? Where was that? What did I do? Did I leave it on this? Yeah. So let's go back here. Everybody remember? Whenever it's a right angle triangle, which two rules you're going to be using? Pythagoras or trig ratios. When it's a regular triangle, what's the rules that you could be using? Either the sine rule or the cosine rule. Okay? So based on what we have here, what type of rules we should be using? Either the cosine rule or the sine rule, right? Do you know when to use one or the other? That's a question for everybody. Do you know the difference between the two rules? I'm going to pull up the rules quickly to just show you. I want you to make sure you have this. All right, I need you to take a picture of this because this is a summary. This should be on your summary sheet. You use the sign rules for these 3 rules here. Everybody watching, if you're watching, I need everybody to let me know that they're logging. You with me right now? But this is very important. This is the foundation of everything we're going to learn and do and practice. So if you don't know this, everything we're going to do going to be confusing. So there we go. The sign rule. These are the 3 times when you're going to use the sign rule. First of all, is when you don't use a right angle triangle. And we know that you're using a regular triangle. It says when you have 2 angles and 1 side. That's pretty easy. So you're either using 2 angles and 1 side, and or you're using 2 sides and 1 angle. But where's the angle? The angle should not be between the 2 sides. Everybody see what I'm saying? So look at the examples here. Here, what do we have? We got 2 angles. Everybody seen it? And 1 side. That's when you could use the sign rule. Everybody seen it? The second time is if you got 2 sides and an angle, but it is not in between. And you know how I just tell students to remember? Sin is bad. So sin is no, not between. So not between. So I have a question for you. Let me just draw this quickly. Can I use the sign rule for this triangle? Everybody, let's go. Can I use the sign rule for this triangle? Excellent. I cannot, because where is the location of the angle is in between the sides. So this is not a sign rule. You can't use it. Excellent. So that's the sign rule. Cosine rule now. These are the rules for the cosine. Look at them here. So you could use the cosine when you got 2 sides and an angle, but the angle is between. So cosine allows you to use this rule when the angle is in between. Everybody see it? Or if you have the 3 sides. So if you have the 3 sides, you could use the cosine rule. Or if the angle is between. So let's go through the checklist. Sine rule is not between. That's when the angle is not between. And cosine is when the angle is between. If you got it, say got it. Because now we're going into the examples. Now, from here, everything is going to be algebra. When I say algebra, you know how to substitute, no? If somebody give you a formula, once you know what each letter represents, you should be able to substitute and calculate. So because this is the first question, I'm going to take it slow, but I'll let you all know, after this, we're going full speed ahead. Okay? So let's take it slow for the first one. Now, my first question to you is, do you see the 3 shapes? There are 3 shapes here. Do you see the 3 shapes? Is yes or no? Only 2 persons saying yes or no, and I'm waiting for everybody else. Do you see 3 shapes? What's the 3 shapes you're supposed to be seeing? Because remember, math is about assessing, critical thinking, and then you apply what you know. It's 2 triangles and 1 quadrilateral. Excellent. You see the 2 triangles? So the smaller triangle over here, the bigger one over here, and overall, how much sides this got? 4. So that's a quadrilateral. Okay, good. So let's read the question. The diagram below shows 4 points PQR on level ground where pillars will be placed to mark the outline of a foundation. Okay. So that means each point represents a pillar, a point that encloses an area. It says there is a vertical post, RT. This question had by, there we go, but we got this. There's a vertical post, RT, But when you look at the picture, is there a T? Do you see a T? You realize what I mean, right? Do you know? And I want to train y'all from now. Anytime they give you a picture and you read a sentence and there is no information in the sentence, guess what you got to do? You got to draw T. What vertical mean? Vertical A mean it's going all the way up. So I would just take my pencil and draw up this here like that. And I will label here what? T. Everybody see what I'm showing you? All of these things here, see, let's look at it. So let's read the next part now. Here, they tell us the topic, boom. The angle of elevation, so let me underline that. The angle of elevation of the top of the post T is 21 degrees. Find the height of the post. This is the topic. This is angle of elevation and depression. So you have to form your triangle. Which part you think you got to connect T? Let's suppose you ain't seen this. Which part you think you got to connect T? Into the Q. Everybody see what I'm showing you? So you're connected here. Let me know if you're following. All we did was put in T. Where do you think we got to put in 21 if 21 is the angle of elevation? First of all, everybody should know what elevation means. Elevation means that you are increasing up from a ground level. That means you're going upwards. Okay, so somebody said they think 21 should go here. Which point you think 21 should go? 21 should go here, 21 should go here, or 21 should go here? Everybody pick an answer, even if you're wrong, I don't care. Pick a letter, Q, T, R, R. Q, T, R, R. Let's go. I need to see. Making mistakes now so you understand why not or why it is. Q, T, R, R. Yup, it is by Q. You know why? Let me just quickly show you. I just want to make sure I quickly show you guys everything now. Let's look at angle of elevation. Look how the angle of elevation is. Look how it looks. It's always the angle of going upward. So you see, this is the angle here, the angle of elevation. The angle of depression comes downwards and it's the same thing as the angle of elevation because you see the Z. For those who don't know what letter Z means in angles, it's called alternate angles. It's another type of angles that you should know, right? So this is how it looks. So everybody see why it's the one that's at Q. So let's go back and take a look. I'm making sure I show y'all the notes one time so you can see. Sorry about that. Let me just zoom out. Okay, where were we here, right? So everybody see why now it's the one that going upwards? Talk to me. All right, so this is our right angle triangle here. Because if we're going upwards, this has to be our 90 degree. So we have a triangle that we're gonna take out. Let's just draw it out as if it's, forget everything else. Because all we wanna know, the first question asks us for what, the height in it. So let's pretend that this is all we need. So let's insert, this is Q, this is T, this is R. Here is our 90 degree. Don't look at how the picture look. It's just at a weird dimensional angle. So this is 21. Which line is the hypotenuse? Let me see who's thinking. Which line is the hypotenuse? Is it QT, QR, or TR? I'm waiting for everybody, you know, let's go. Which line is the hypotenuse? And this is why it's too, I'm gonna be honest with you, you know, this is a setup question. You know why this is a setup question? QR look like the hypotenuse, but based on what you should know, where is the hypotenuse? The hypotenuse in opposite of the right angle. Talk to me. You see what I'm showing you? Remember we spoke about that? So this question, a lot of people fail this question because they use the wrong side. Talk to me. Everybody see what I'm saying? So this is your hypotenuse. So which one is your opposite? Which line is your opposite? TR or QR? Which line is your opposite? Who tells us where the opposite is? In the one that facing the angle. If this is the angle 21, which one opposite the angle? Opposite the angle. This is opposite. That means that this is going to be what? Adjacent. How do I know that this is adjacent? It ain't touching the angle. Everybody see now what I'm trying to show you? Hypotenuse is opposite the 90 degrees. Opposite is opposite of the angle. Adjacent is next to the angle. If you get it now, tell me if you got it, got it. Because if you ain't got it, we can't go no further. You get it now? Okay. Now, what the question asks us, find the height of the post, TR. So they gave us a number here, 153. 153 meters. Which two sides we need to use then? Which one they ask us for? A and TR. So which operation we're going to use? Are we going to use sine, cos, or tan? You should know because I tell her right on the formulas. Which two we're going to use? If we want the opposite, which is TR, what side did they give us? They gave us the adjacent because that's 153, right or wrong? Which one deals with the opposite and the adjacent? Tan, because sine is opposite over hype. Cos is adjacent over hype. And tan is opposite over adjacent. Everybody following me so far? So let's write the formula. Tan theta is equal to opposite over adjacent. Let's substitute. Do we know what theta is? What is theta? Theta means angle. So what's the angle they gave us? So tan 21 is equal to opposite. Do we have the opposite? No. So let's use X to represent the unknown over the adjacent. What is the adjacent? $153. So let's pause right here. What do you do next? Tan 21 has a numerical value. So get your calculator, put it in and tell me what it represents. What is tan 21? Okay, so I got 0.383. Anybody else? What is tan 21? Type it in your calculator, tell me where you get. 0.383 is equal to X over 153. If I want X, I need to get rid of divide by 153. This is algebra. How do you get rid of? It's 10 o'clock? Okay, then maybe I'll put some pep every step. Thank you so much, guys. Thank you so much. So after this, I'm going to be moving fast, okay? So to get rid of divide by 150, I got to do the opposite, which is multiply by 153. Whatever you do on one side, you have to do on the other side. So that means what's going to happen over here? This and this going to cancel. So we're going to left back with X. So that means X is equal to everything over here, which is 0.383 times 153. What's my answer? What is X? 58 point. And what did we just find? Now, everybody calculator going to be a little off, but once you get the same thing, 58 point, round it off, 6, 7, it would be the same thing, right? To 1 dp. What did we find in the missing side? So it must have a unit, meters. Everybody with me? Look at it here. See, we got it. 58.73 is the exact figure. But if you have, they would give you a chance and they would tell you if to round it off. But generally write it to 2 dps. So if you get 7.363, don't panic. Everybody calculator just give different degrees. So once you got 58 point something, you're gonna get the answer right. So everybody see how we did that? That was the first example, eh? So when you have that information, you go back to your drawing, right? You have to go back to your drawing and you're gonna put 58.7 here because that's what we just found. So the next thing now, what they asked us for, given the length of QS is 135, let's go back to the picture. What is QS? Anybody see QS? QS, y'all with me, right? So QS, they gave us, what is the length of QS, they say? Is 135, right? So you write it in your drawing, this is 135. Let me see if anybody thinking, what they ask us to find. They say calculate the perimeter of the foundation PQRS. So let's look at that. Find the perimeter. What perimeter means, everybody? You see how they just ask questions? First of all, what perimeter mean? If you don't know, tell me you don't know. Because we almost finished this question. What does perimeter mean? Perimeter means you have to find the total length of all the outside sides. So you got to add up all the sides. Everybody with me? So there we go. Do we have all the sides though? We have the first one, the second one, and the third one. So who missing? What letter missing? In PS missing? No, let's look inside here. Anybody could tell me what rule we got to use to find PS? Where is the angle? Is it between or not between? And you're going to tell me which one you think it is. Is it the sine rule or the cosine rule? Let me see if you all remember what we just talked about. Everybody see where is the cosine rule? Look at it. They gave us 135 and they got 83 here. Where's the angle in between them? Let me know if you see it, people. Let me know if you see it. So that way, we're going to use this triangle to find the missing side so that we could find the side that we need for the overall shape. So I'm just going to go here where they have the formula. So the first thing you always start off with in applying, you see, apply the cosine law. So I want everybody to tell me if they understand why we use the cosine law. Yes or no? Okay. Because the angle is in between. Right? Okay, good. Now, I am going to do it the long way, just to show you, because even though this looks so easy, in your book, it ain't gonna be so easy. So I'm gonna do this out for you now, and in the future, I won't not go through the whole entire thing, okay? Is that okay? So I would prefer if everybody write down this example with me, and then from there, we go from there. So let's say if this is angle A, this is side A, and this would be B, and this would be C. Do everybody agree with that? Because that's the first thing you have to make sure you label properly. Do you agree? Any angle they give you is angle A. And the side opposite the angle is the letter, right? So what is the formula? The cosine rule says that A square is equal to B square plus C square minus 2BC cos A. Okay. I need to know if you are ready, because I'm going to go through this slowly so that you understand. So I need to make sure everybody watching. All right. Do we have a squared? No, so you put it back. So I'm gonna write in blue, black. So you're gonna write a squared because we don't have it. Do we have b? Yes, 83. So that's gonna be what? 83 square plus 135 square. Everybody following so long? This section here, how many things we multiplying? You know, we're multiplying four things, right? We're multiplying 2 times b times c times cos a. So it's gonna be 2 times b. What is b? 83. And you know, brackets mean to multiply, right? Times c, which is 135. Times cos a. What is the angle a? 29? Cos 29. Don't cos 29 have a number? So let me go through this together, everybody. Calculators ready. I just need the answers. 83 square is what? Let's go, peoples. Everybody got to be working together. So one person do 83 square, one person do 135 square. So I need somebody to back check. Excellent. 6889 plus what's 135 square? I see in 2 different things. Which one it is? 18225. Somebody could confirm, yeah? That's the answer. Excellent. Is it 13225 or 18225? Please back check. You see how all of us getting different answers? There's only one answer. Which one is it? Please back check your calculations. So what I have is right. Okay. So it's going to be 2 times 83 times 135. What is cos 29? That's a number. What's cos 29? 0.872. Is that true? Or 874? Which one? 874. Okay. No, I want everybody to tell me. I want everybody to get an answer for me. I want to see if y'all could get an answer. Everybody get an answer for me here. That's a very important skill. All I want, everybody get your calculators. Finish work out this for me and tell me where you're going. Are you going to get my answer? I need you to get your own answer. So I see one answer here. Is there a decimal point that's supposed to be there, Richie? Check it for me and let me know, or that's your full answer. Because if you don't put a decimal point, it's wrong, okay? So 6889 plus 18225 should give you 25114 minus, and then when you multiply 2 times 83 times 135 times 0.874, you get 19586.34. And then you subtract them. You're supposed to get 5527.66. Excellent. No, if your calculator give you 7.5, did you round up? Everybody, did y'all round off properly? Let me do cos 29. Let me see. Cos 29. It's supposed to be 875 people. How we not rounding off? Everybody check it to see. You won't get it wrong because of that, but you want your answer accurate as possible. Everybody see why it's 1875? Because you get 0.8746 So the 6 gonna change it to a 5. All right, so excellent. So everybody, do you see how to use the cosine rule? It's not that hard, it's just substitution. And so now we got to remember we didn't answer the question because they didn't ask us to find PS. You go back every time you finish do something, go back and check to see if you answer. So PS is this. I wonder if anybody realizing. I ain't saying nothing else, even though the answer right there. Why is the answer not this? Don't worry about the actual digits. Like that happens when you have when you change this to the 5, this is what you would get. That's the only reason why the 19 is a little different because it's going to be a little higher, okay? You have to square root it because we didn't ask for a square. They want a. So we can't use this number. So to get a, you must square root both sides. That is what I was waiting to see if everybody remember. So that's why a is equal to the square root of that. Please use your calculators. Make sure you're getting the right things. You should get 74.34. If you use this number, you're gonna get 74.34. 35 actually. 35. And then you take this number and you add it to the other sides, which is what I did here, and that's how they find the perimeter. Okay. All right. So that was our first slow zoom out. Okay, sure. So that was our first question. This topic had circle theorems and angles of elevation and a bit of the cosine rule and the sine rule. Out of 10, how you feel about what we did? Even if you ain't remember everything, I want you to tell me about your understanding. That's what we want to make sure we get a little bit stronger at, understanding. Out of 10, what you would rate your understanding of what we did. So we're going to move on to the next exam, which was June. I'm watching now, so keep please showing, and thank you for your honesty. Please know that you have to pay attention to what you don't understand here and put in the extra work, okay? Right? All right, so we're going into January 2023. That's what we just did. Why is this here again? Did I do it twice? Come so. Or am I going mad? Am I going mad? Why am I seeing the same exam over and over? Oh, okay. All right, so let's go through this one. Now, guys, this exam, I'm going to go through a lot faster because of the time. We have to at least try to finish 3 more exams. And then we're moving on to question number 10. Okay, so all I want you to do is follow and pay attention. Okay, so here is 2022 June, last year June exam. A lot of people, did not do well in this exam, as we all know. So let's see how we can make sure we follow along, okay? It says H, J, K, L, and M are points on the circumference of a circle with a center O. MK is the diameter. So you see, you should already be picking up that if this is the diameter, we should have a triangle, which should be 90. So I'm just going to plug it in so you can see. So if this is the diameter, I'm looking, you see, it got a lot of triangles. Everybody seen the several triangles in this thing. I also see a quadrilateral. But do you see the angle that's 90? Look at it here. This is the one that's touching the circle, the diameter. So that means here is 90 degrees. They asked me for it yet, but I done looking for it already. Everybody see that one? So that's the first rule I see. That's the 90-degree rule. Another rule I see is the opposite angles in a quadrilateral. So let me highlight the quadrilateral first. So the opposite angles in the quadrilateral add up to 180. Everybody remember that one? All I need you to say is yes or no, that's all. So these two add up to 180. Everybody see that one? Okay. Do you see any others? I see the 2 dashed lines, so that means an isosceles triangle is somewhere. So let me see if I can find the isosceles triangle. Look at the isosceles triangle here. Everybody seen it? So that means this angle and this side is equal. That means that this entire angle here, this whole thing, not just the 38, 38 is just a small piece. And this angle here is equal. And that means that these three are equal. If you think about it, well, not equal, but they're related. All right, is there any rules that I'm forgetting? Anybody seen the parallel lines before I even continue? Do you see the parallel lines? And if you see the parallel lines, you should see the Z. So look at the parallel lines here. The arrows, that's one parallel line. That's another parallel line. Do you see the Z? Look at the Z. Remember alternate angles are equal. So that means if in here is 38, if in here is 38, that means here is 38. So do you realize that I already done find so much angles already? Everybody see what I'm showing you? We found the 90. We found the ones that are opposites, that, you know, they add up to 180. We found the alternate angles. We found the isosceles triangle. So we know that those two angles over there matching as well. Yeah? I hope everybody with me. All right, so let's take a look at the question now. Did I miss anything? Is there any more rules that I didn't see? Anybody seen the twin angles? I see the twin angles. Oh my God. Tell me if you ain't see the twin angles. Do you see the twin angles? Excellent. Excellent. L and K, look at here. Guys, if you don't see them, you can't answer the questions. And that's why I'm making sure you see them. So this is one of the twin angles. They're upside down. And this is another one of the twin angles. So that means this and this is equal. Yeah? All right. Do we have any more? Let's check again. I don't see any angles at the center. I don't see any angles. There's no tangent. Oh, you see it now? Okay, good. That's all I want. I just want y'all to see it. So I think that's it. So there's no tangent. So there's none of that there. I see a radius, but no tangent. So I think we should be good to go now. All right, so let's go to the first one. Explain, given a reason why angle HJM is 38. So you see, this is the next one. They give us the angles and they want to know why. So let's find HJM. Everybody look for where you think HJM is. Look for it. H, follow the line, J, M. We didn't find that one before. Who could tell me what an angle equal to? It's 38. Why is it 38? I gave you all the answer before. What's the reason? This ain't in the Z. And what angles form a Z? What do we call that? No, not the zilla, alternate angles. So this is alternate angles. That's the Z shape. That's what you call a Z angle. Or the Z shape angle. If you got it, say got it. That's the reason. Here they have some long drama saying that the diagram shows MK is the diameter and the circle and it's parallel. So if it's parallel, they are equal angle, blah, blah, blah. Okay, good. All right, let's go. Next one. The next one they ask us to find is MJK is 90. So let's find MJK. They say state why MJK is 90. This is M, J, and K. We didn't do this one just now. Why is MJK 90? Who could tell me why MJK is 90? Which rule is this one? This ain't the one with the semicircle. Look it right there. So the reason is because the angle is formed on the diameter, which is what we call angles in a semicircle. So let's go back. I just saw it. Where is it? Which number? Number 1. Everybody see that? Angles in a semicircle. Angles in a semicircle is 90. So that's it. I went back too much. Is this question? Oh, this is it here. All right, next one. It says, where's the next question? That's B. Where is C? Something missing. A, B, C. I'm not sure. I think something missing. Let me see. Let me go up. I have the exam. Somewhere else? Something missing with this one, but let's just read it to see if we understand. All right, so here, what they're asking us for here, JM is equal to JL. Let's look at where JL is. Okay, I think they're talking about where's JL. JL and MJ is the isosceles. Okay, everybody see the isosceles? Remember we spoke about the isosceles before? I don't know what the question for this part is. I'm going to look for it after so we can understand it better. So we're going to skip that one for now because I can't really go through it if I don't understand what it asks us to find. So let's just do C for now. Find angle JHM. So let's find JHM. JHM, where is that? JHM. No, the truth is they already found this one here. And I think this one they said was 52, right? Yeah. So if this one is 52, who could tell me how to find the one at up here? What do we do? Which rule is this one? Because we spoke about it in the beginning again. How do I find, how are these two related? They're in the cyclic quadrilateral. That means they are opposite. So what does opposite angles in a quadrilateral do? They add up to what? Anybody remember? Should I go back again? Cyclic, both of them add up to what? Opposite angles in a cyclic quadrilateral add up to 180. You see how you just got to remember the rules? If you don't remember the rules, there's nothing you could do. So H is just simply saying 180 minus 52, which is 128. Look at here. Everybody see? You could either use this quadrilateral, you see which one they use, or you could use this one that we have here. Same thing. All right, next one, bearings. No, be honest. How much people know how to do bearings? Yes or no? I don't. Yes. Not sure. Let's go, guys. Talk to me. We don't do one angle of elevation and depression. Now we're going to look at a bearing question. So somewhat. No. Okay, majority of persons are saying no. Okay, so bearings has to do with angles, right? All I need you to know is that a bearings is an angle from a knot line. So if we look at this picture, so I'm going to use this to teach and to like review and to explain. Okay. Now bearings are right written with 3 digits and not 2. So here they say from a point, and is the point that they say from is what they're talking from, is where the knot line should be. So let's read this. From a point, a port L. So let's look at the picture. Everybody see L? And because they say from L, that's why the knot line is drawn at L. Everybody with me? So the bearing, I'm just going to explain two things. There are two bearings in this picture. The first bearing is L to R, and you measure from here to here. That's the angle in between here. That's the first bearing. The second bearing going to which other letter? Anybody could tell me what's the second bearing going to? So the first one gone to R. Where the second one going to? Look at the picture. So L goes to R. Where else L goes to? To T. Everybody see that? Look at where we're connected to L as well. Do you see it? So there's an angle from the north line all the way down to the line that goes to T. So let's make sure everybody understand that. Everybody understand the two bearings? The first one is from L to R, which is this angle here. And the second one is from L to T, which is this angle here. If you got it, you got it. That's the first thing you just got to understand. There's two bearings. One that goes to R and one goes to T. And you always measure your bearing from the north line. Okay? All right, so let's read what they tell us. They say the shape R is 250 kilometers on a bearing of 65. That means that this angle in between here is how much? 65 degrees. Do we agree with that? So that means from here to here is 65 degrees. Everybody agree? And they gave us the distance. Now you realize some of the information they put in the diagram and some they do not. You get marks for completing the diagram, eh? So let me see what the first question says. Complete the diagram by inserting the value. You see, look at that. They ask you to put in the information in the diagram. And then they say ship T is 180 kilometers on a bearing of 148. That means this big angle here is how much? 148. Everybody see that? Would you be able to do that in the future? Understand that first step? Yes or no? So I could know if I could move on. All we did was take the information and put it inside the diagram. So we know the first bearing is 65 from the north line. The second one is 148 from the north line. Yeah? All right. Now, I could figure out something. Anybody could tell me how to get the angle inside here then? Let me see who's thinking. Even before we read the question, what is the angle inside here? What do you think you have to do? Look at it. If from here to here, let me just use the arrow. From here to here is 65, right? But this entire thing from here all the way down is 148. How do we find from here to here only? How do we find this extra piece here? What do we do? Y'all got to learn to bust your head. Let's go. Somebody, what do we do? Do we add numbers? Do we subtract numbers? Do we multiply? Do we divide? What do you think we should do? So Cheyenne says subtract 65 from 148. Do we agree with that? Wouldn't that make sense? If all of this together is 148, from here to here is 65. So to find the rest piece, we got to subtract. Everybody see that? Tell me if you're seeing it. Yup. So that means, let me just erase this quickly. That means the angle inside this triangle is simply what? 83 degrees. Yup. Yep. So let's read the question now. It's a completed diagram inserting the value of RLT. What was RLT? RLT. Look, RLT is 183 here. 183. How did we get a? Look, it says here. If the bearing is 65, is 148. So look at it here. The angle is 148 minus 65 equal 83. This is illustrated on the diagram below. See, that's it. All right, next question. Determine the value of each of the following angles. Show the details without working. So that's it. That's easy. What? That's it. That's an easy question. If y'all get a question like this, y'all lucky. to be honest with you. If you get a question like this, you are very, very lucky. I think something mixed up about this though. I think so. All right, I think it's this question over here next. All right, I think this gets scrambled because I put it in the right order, but it's not in the right order, no. So let me just come back to this whole exam. This whole exam gets scrambled. I don't know how come. Yeah. Yeah, really? So let me just come back to this exam after. So let's move on to another one. Practice. We're going to just move on to January 2022. Let's look at this picture here. Let's look at all the different lines that we see. Everybody should see the tangent. Look for it. Everybody see the twin angles. What's the letters of the two twin angles? This time you just got to tell me if you see it or not. What is the letters of the two twin angles here? And I'm telling you now, if you can't learn to see them, you're going to not be able to answer questions. Find the twin angles. So somebody said R and Q. Is that true? Yes. These two are twin angles. Very good. What about the semicircle? You see the angles in the semicircle? Do you see the diameter and the angle that's going to be 90 degrees? Do you see it? Look for it. This is the diameter here. So that means this angle here is 90 degrees. Everybody see it now? Next question. Do you see the radius and the tangent? Look for the radius and the tangent. So this is the tangent. Where is the radius? So that means that this angle is what? 90 degrees. These two angles, when you add them up, going to give you 90 degrees. Yeah? Is there any more? Did we miss anything? Did we get all? I see the internal and external angle. Anybody see the internal and external angle? What letter is the external angle? Tell me what is listed by the external angle. What is by the external angle? What is labeled at the external angle? Excellent. And 3x, look at it. Look at the external angle. Remember, the external angle is the angle on the outside of the triangle by the tangent. This here. This ain't that. What number is it equal to? Let me see who's thinking. Internal, external opposites. What is 3x equal to? No, try again. Look at the triangle properly. This is the triangle here. Everybody, let's go. What is 3x equal to? It's only two options you have. It's either 54 or Z. Which one? It's 54. Because what side is this? They say in the right-hand side. So inside opposite would be inside left. What's the inside left? 54. All right, so that's it. So now let's answer the questions quickly. It said find X and state the reason. Where is X? Now X is easy to find. Let me show you why X is easy to find. You have two things that you could use. Look where X is. X is here, right? But where is this inside of? This is inside this triangle. We don't have everything we need to find this angle here. So we got to use another way to find what X is equal to. Now, there's two ways you could do this. Look at where you have other X's. Those other X's ain't inside this 90 degrees. So these two don't add up to 90 degrees. Talk to me if you see it. So it means then that 2x plus 3x equal 90 degrees. This ain't algebra. 2x plus 3x is 5x. So 5x is equal to 90. So how do I find x? We divide by 5 on both sides. So x is equal to, what is 90 divided by 5? 18 degrees. Look at it here. If you got it, say got it. You see how algebra coming into play? All I want to make sure is you're following and you're seeing the possibilities, right? No, let's be real. If we know what x is, don't we know the answers for all of these here? Because if this is 3x, this would be 3 times x. Agree or disagree? If this is 2x, this is 2 times 18, and x is just 18. Yeah? So let's look at the next thing they ask us for. They ask us for y. Look at where y is. We know what x is. Everywhere you see x, you put 18. So this is 18. We don't know. Let's highlight what we want, because I don't want you to get confused. Let's highlight where y is. Where y is, y in the triangle I got in the semicircle. Look at where y is. Everybody see where y is now? So if this is the semicircle, that means all of this angle here is how much? 90 degrees. How do I find y then? Don't I have 2 angles out of the 3? So y is equal to 180 minus, when you add the 2 angles that they give you, which will be 190 plus 18. That's your answer. That's how you find your answer. Everybody see why? 3 angles in a triangle add up to 180. We have 18 degrees and we got a 90 degrees. So that's the law. That's the theorem. So you add them up and you subtract from 180. So y, look at you. See the 90? Same thing, 72. So we put in our picture 72. Y'all following me, right? Even though y'all ain't saying nothing, I just want to make sure. Please tell me if y'all following. Y'all following? And the more you practice, the more you're going to realize that this ain't hard. You see what I mean? Okay, now let's look at it. Now that we have y, do we need to calculate z? Do we need to calculate z? No, because y and z ain't the twin angles. So we know what twin angles mean. If y is 72, what does that mean? That z is 72 as well. See how easy that equal is? Just so, boom, bam, bam. All right, and guess what? We're done. Now, let me ask this question. How do you feel about circle theorem the more we practice it? Feeling better? It becoming a lot clearer for you? And I hope you're also noting that you need to know your theorems. If you don't know your theorems, you're going to kind of be struggling. Feeling better a little bit? Okay. All right. So let's get into this one now. What does it look like to you? Once you see the knot line, what topic is this? Once you see the knot line, what topic is this? Bearing. Thank you. Everybody agree? Now, in this diagram, you realize they give us a lot of things. So some things I want you to pay attention to. Do you see the 3 shapes? Yes or no? The 2 triangles and the 1 quadrilateral, right? Okay. So you got the 2 triangle, triangle 1, triangle 2, and the overall quadrilateral. So let's read the question. The diagram below shows straight roads connecting the towns L, M, N, and R. LR is 18. Let's make sure that's labeled. That's labeled correctly. Good. So that's in. LN is 12. Where's LN? LN is 12. Good. MN is 10. Always make sure that the information in the picture. Angle RLN is 25. RLN is 25. That's there. And angle LMN is 88. So this exam gave us all the information we need. Okay. So everybody see what's going on, right? So let's read the first question. The first question asks us to calculate MLN, the angle MLN. So that's this angle in here. Question for everybody. Do you know how to do that? Let's look at what they gave us. They ain't give us the bearing, so we can't subtract. You realize that, right? So look at the triangle. What is triangle gave us? It gave us two sides and an angle. Is the angle between or not between? So which rule do we use then? The sine or the cosine? Excellent, guys. Excellent. You see the difference between the two? I hope y'all realize that's all you're supposed to look at. Look at what they give you and look at if the angle is between or not between. So the angle is not between, because look at it. This is 10, this is 12, and look at where the angle is. It's not here. It's away from the in-between sides. So that means we're going to use sine rule. Now the sine rule formula is in the front of the book, so you just go for it. And it says A over sine A is equal to B over sine B. Now, look at the one that you have matching. Do we have a matching side? Which one would you think as your A? Your angle A and your side A. Which one do we have already? Both a matching pair. What numbers we have matching? Let me see who's thinking. Remember, the A and the small a are opposite each other. The small a is the side and the big A is the angle. So what number should be on the top here? And I'm not telling you, it wouldn't be 10 because these two match and we don't have them. We don't have both information for both of them. We're using the one that we got both information. So which one we have both side and opposite angle in these two? Everybody see what I'm showing you? These two are already matching pair they gave us. So this would become 12 over sine 88 is equal to B. What would B be? What is the number B? 10 over sine B. They're saying what we're trying to find. So let's go. All this requires now is for us to finish calculating. 12 divided by what is sine 88? So Simone says 0.99. Is that true? What is sine 88? Everybody get your calculators. Let's go. All I ask y'all to do is do the calculations and send what you get so we could all make sure we could get the answer. Sine 88 is 0.999. Use 3 decimal places. Equal to 10 over sine B. We don't have a sine B, so we gotta leave it like that. What does this mean here? 12 over this. What does that mean? Doesn't that mean division? So divide 12 by 0.99, you should get 12.012 is equal to 10 over sine B. So let me just know, everybody with me until this point? What do I want? A and B? No, let me tell you all this. Anytime the thing that you want is in a denominator, just switch these two. I don't have the time to go through explaining why, but if you know algebra, you know that that's correct. Switch these two. So instead of this, you're going to end up with sine B is equal to 10 divided by 12.012. So what's my final answer? Sine B is equal to 0.832. Is this the final answer? No. They didn't ask us for sine B, they asked us for B. So to get rid of sine, we do sine inverse. Whatever you do on one side, you have to do on the other side. So sine inverse is going to cancel sine, and it's going to leave us back with B alone. So B is equal to sine inverse of 0.832. So put this in your calculator. If it's anything that I want everybody to do is put that in your calculator and tell me what you get. So B is equal to what? I got one answer, 2, 3, 4, 5. Excellent job, guys. Suppose they say round this off to the nearest degree. That means round this up to the nearest whole number. What is that? What is this rounded up to the nearest whole number? Excellent, 56. So now we get a perfect example of how to use the sine rule. So if you want to take a picture, I suggest that you do so. And here you got it two ways. You got a way, this is the advanced way. And here, this is the explained way, so that you understand everything that happening here. Are we good to go? We're gonna wrap up this topic just now. We're gonna do one more exam and then that's it. Can I move on, guys? Okay. The next one they ask us to calculate is the distance NR. So let's look at NR. NR, right? I'm just gonna use this picture here. This is easy. When you look at NR, which rule you think you got to use? The sine rule or the cosine rule? Because you're gonna realize it's the same thing we're doing back to back to back. Every year, it's either the cosine rule or the sine rule. It's just for you to determine which one. So everybody look at this triangle here. Tell me, how do you find NR? Do you use the sine rule or the cosine rule? I need people to answer. And people who are not saying anything, I'm gonna kick you out of class. I know some people busy, but some people not saying anything at all. So I don't know if you're learning, if you understand what's going on, you're not sharing. So let's go. So I have 3 people who answered. Look at where the angle is. The angle is where? Between or not between? And that should tell you whether it's the sine or cosine rule. So we got 2 sides. The angle is between. So when it's between, it is the cosine rule, right? Simple. And we don't know an example of how to use it. Remember the formula? A squared is equal to B squared plus C squared minus 2BC cos A. And you just work it out. Everybody remember how we did that? So I don't need to go over this, right? So this should be good. Confirm, confirm. We understand how to use the cosine formula based on what we did before. So we understand why and we understand how. So that's all we're going to be doing from now on. Looking at the question, make sure we understand why and how. So that's it. Use the cosine rule, you find your answer, that's your answer, boom. Good. Now, the last one says, determine the bearing of tone R from tone L. Tone R from tone L. So what does that mean? That means when you're looking for a bearing, you always start from what? In the knot line. So if it's from L, yes, that's right here. So that means we start here and we got to go all the way down here. Right or wrong? Anybody could tell me what I have to do to find that bearing? Everything you need here is in the picture. So what do you do? Let me see who's thinking. Anybody? Excellent. Add what? Tell me what all you should add. In all 3 angles. Look at it. Excellent. Because from here to here is 50, from here to here is 56.4, and here is 25. So to find the bearing all the way to R, you just got to add all the angles in between there. Everybody's following me? I just want to make sure you understand. You realize bearings ain't that hard, to be honest. You just got to practice as much as possible. So if you got it, say got it. Look at it here, you just got to add 131.4. Just add all the angles. They gave us this one, we found this one, and then they gave us that one. Guess what? We're done. That was it. That's the whole exam. So now I have a question. Out of 10, how you feeling about question 9 at this moment? Know that we did cosine, we did the sine rule, we did a few circle theorems. Like, how you feeling? How you feeling? You think you could get at least 50% of the marks? Even if you don't get all, you should be able to get at least half of the marks for this question. So let's do one more for the road. One more for the road. So we're gonna do June 2021, May 2021. And then we're gonna finish with that. How much you want? One more, at least 2 more. Should we go to January 2021? So everybody tell me no, 1 or 2? 2 more? So let's skim through this quickly then. We're gonna just go through it fast. All right. Let's look at the circle theorem. Let's talk about some things that we should be seeing. Do you see the tangent? The one tangent. And I need people to answer yes or no fast. That's all I need. Some of y'all are taking too long. So everybody see the tangent, right? AB, excellent. Very good. Now, do you see the diameter? Do you see the diameter? Good. Do you see the external angle, the outside angle? Here, right? Good. Do you see the parallel lines? Look for the parallel lines. CD, excellent, and AB, right? So CD and A. Whenever you see parallel lines, what letter you should be looking for in the Z? Do you see the Z? Also, do you know that there's a backward Z and a forward Z? Let me draw the Z. Do you see the backward and forward Z? Tell me the truth. If you don't see it, you don't see it. So this forward Z is easy. This is the forward Z. So the forward Z would be in here is equal to in here. That's straightforward, right? Now let me show you the backward Z. The backward Z is more leaning. Look, the backward Z here. This. Everybody see the backward Z now? So that means in here is equal to all of this in here. All right. Any more rules? Then am I missing? Am I missing anything? Anybody see the rule with the radius and the tangent? The radius and the tangent. How many? What angle does this create? This does create what? The 90 degrees, right? On both sides, eh? Excellent, guys. Excellent. Anybody see the opposite angles in the quadrilateral? Do you see the quadrilateral? Let me if you're seeing it. The kite, excellent. So that means this one and this one add up to 180, and this one and this one add up to 180. Do we see the 90-degree triangles on the diameter? They got 2 of them. Tell me if you're seeing them before I draw them. They got 1 on each side. So if you look at it, this is the diameter, right? This is 190 degrees. Right or wrong? So that's 90 degrees here. And look on the other side. This ain't 90 degrees too. This is 90 degrees right here. I think we get all now. Excellent. Excellent. All right. So y'all think y'all could answer some questions? I want you to try to answer them first before we do them together, okay? So now let's look at what we have here. It says, I don't know what all this in red is about. Oh, what they're saying is, right, that some people could get different. Apparently this year, they realized that you could get different answers based on what law you use. So they made some special, adjustments to the accepted questions and answers. The angles given on the diagram are geometrically incorrect because the angle CFE should be 68. Where's that? CFE. CFE should be 68, which is right. This is supposed to be CFE. Why would this be CF 68? Anybody could tell me which rules that said it should be 68? This ain't the internal and external. Look at the triangle here. This is a left hand external and you have an internal right. So everybody see why they're equal? Talk to me, yes or no? Okay, so what they're saying is that, yeah, that was supposed to happen. So some people could get different answers. But let's see what we get. They say find ECD. Where is ECD? ECD. Anybody could tell me what ECD is? Do you know ECD gonna be 68? Why would it be 68? Look at the Z. Do you see the next Z? Look at the Z. So that means in here is equal to in here. Everybody see it? Alternate angles. Okay. See, where is it? So where is it? Yep, look at here, 68. Very good. All right, let's find the next angle too. I guess the next angle they ask us to find. Let me go up here to the question. Angle 2. Oh, this is another thing. They're gonna ask you for the angle and the reason. So your reason is alternate angles are equal. So that's how you get your 2 marks. You're gonna get 1 mark for your answer, 1 mark for your reason. Okay. All right. They said find CEG. Where's CEG? Let me erase all of this. CEG. We know this is 68 as well. And you know what, it's wrong. Look at that. If this is 68, these 2 8 supposed to add up to 180 because it's on a straight line. Everybody see why this exam went wrong? Because they didn't work it out properly. So CXC does make mistakes sometimes. So please note, if you feel 100% confident with your answer, leave it, okay? So ECG. How do we find ECG? ECG ain't easy. What's ECG, people? ECG. What is the angle there? We ain't talk about the angle there. What is the angle? I'm not saying it. What is it? Excellent. 90 degrees, because that's the angle in the semicircle. Very good. Thank you. That was a direct question. 90 degrees. What was the next question they asked us for? Let me use up here, see, because that they're confusing. CGF. CGF. Where's CGF? CGF. How do we find CGF, guys? CEG. How did they find CEG? Anybody know how to find CEG? This is CEG in here. How did they find that? Why is it 90 minus 68? This angle here is 19 total, right? So if the full thing is 90, and from here to here is 68, to find the extra piece, you're gonna say 90 minus 68. That's how you get this answer here, 22. You do the same thing for the opposite side. Yeah? Hello? Do we agree? All right. Now what they're saying is that to find this angle up here, you just use the rule about the opposite angles. No, this is where the problem here came in when they were saying that some of the angles going to be off because of some certain reason. So it kind of had to use these digits because they're going to kind of be mixed up. But the point is, once you find these 2 angles, and we know how to find them, right? You simply just subtract from 180 because you know that's the angle for up here. Because these 2 add up to 180, and that's it. All right, so let's go into, that's the same thing we just did here, 90 minus the 68, look at here, 22. Same thing, see opposite angles, the same thing that I just said, add up to 180, so 180 minus the 38, you get the 142. Same exact thing I just said. All right, so let's go into bearings. This is the last bearings questions. It's 11 o'clock? Okay, we got done. After this, we're done. Okay, I would like y'all to handle this question. Get your calculators. So this is to see if we really understand. So there we go. We have H, Q, and R. And it says that we have a bearing to Q of 069, which is 69 degrees, and 151. What do you realize? Is the 151 in the diagram? People, is the 151 in the diagram? So how do I draw it? Do I draw it from here or do I draw it from the knot line? Which one? That's a serious question, everybody. If the bearing is 151 to R, where do I draw? Where does that angle be represented from? Option A or option B? Let me see who's thinking. Excellent. It must be from the knot line, right? So that means from here to here, that is the 151 degrees. You realize this? We did something similar here. Complete the diagram above to show the information given. Boom. You get 1 mark just for showing that. Everybody see? Same thing I was showing you there just now. So you just wouldn't put in this. Even before they ask, what is the angle A? Let me see who's thinking. How do we find A? If this is 151, let me use a different color. 151. How do I find angle A? The angle inside the triangle. Okay. Okay, excellent. Anybody else agree? It would be the 151 minus the, what number am I minus from? 69. Everybody agree? So let's see what the second question asks. Calculate QR, the distance between the two ships to the nearest kilometer. No, look at that. You just got to find it because you need it. How are you going to find QR without the angle inside here? So everybody see what I'm saying? Always just find the angle. So we got 82. So in here is 82. So I have a question for you guys now. Is this sine or cosine? We want to find this one. Is it sine or cosine? Let me erase all of this so y'all ain't confused. What should the angle is? This is 82 in here. Is it sine or cosine? Look at the diagram, peoples. Which one it is? Look at where the angle is. Is the angle between two sides or not between two sides? Remember, sin is bad, so sin is not between. Cosine is good, so cosine is between. So which one? Don't forget. 82 is between 175 and 242. Look at it. In between the two sides. So when it is between, what do we use? Cos. When it is not between, we use sine. So we're using cos here. You see it now? So, quick question. Remember how to use the cosine rule? Remember cosine rule? If you got it, say got it. It's the same thing we're doing all morning, cosine rule. Four people answer. We got 23 people in here. Let's go. Everybody talk to me. If you see the cosine rule, we did the cosine rule today, earlier. Do y'all want me to do it one more time? If you need me to, say so no. Should I do it? Or y'all good to go? Okay, so let's go. The cosine rule, this is the formula, and you find the formula in the exam, right? A square is equal to B square plus C square minus 2BC cos A. For those who feel confident, I want you to try it by yourself and see if you get back the same answer, please. Those who need some assistance, let's go. What would be my B square? One of them, right? Let's use the shorter one. So that's 175 square. What is C square? The other side, which is 242 square minus 242, sorry, square minus 2 times 175 times 242 cos, what is the angle? 82. So there we go, calculators out. What is 175 square, peoples? I'm waiting for somebody with a calculator because I'm not doing it. So that's 30625. Please make sure you're getting them on the calculator because then it would be like, you know, pointless. 252 square should be something flat as well. 58564. Thank you. Thank you. Minus, what is cos 82? What y'all get for cos 82? Let me see if y'all rounding off properly. Cos 82. Everybody send your answer for cos 82, please. 3 decimal places. That's what you get? Sure. Cos 82. Hassani, your calculator round it off for you. You should be getting 0.139. Because the thing after the 9 is a 1. So that's why I was wondering, how come you round it off? You see what I mean? Everybody see that? Okay, so all you gotta do now is multiply 2 times 175 times 242 times the decimal that we just got just now, which is what? The 0.139. I want everybody to finish this and tell me if you get back the answer. The answer that you should get is at least, when you get A, not A square, so you should get A is equal to 278 kilometers. If you get it, just put got it and then we're good to go. I just need to make sure y'all can finish it by yourself. Finish it, finish it, finish it. Okay, that's one person saying to finish. Another thing is y'all have to work on how fast y'all work. Remember, exam is timed. You get it? All right. And to be honest, once you know how to use the cosine rule and the sine rule, you're good to go, you know. You just got to make sure you remember which one to use and when. All right. So that's it for question number 9. So if you were to go and try to do question number 9, last rank, out of, how much marks is be for question 9? Let me see. I think it is be like total marks is 12 marks. Question 9 usually 12 marks. Do you think you could at least get 6 to 10 marks? That's half, just above half. Tell me how much you think you should be able to get, everybody. Because I feel that you must be able to get a little something from these things. I like that. 11, period. And if you practice on your own and you continue to strengthen your skills, you should be good to go. Okay? So I'm just waiting for everybody else to send me their skills. What do you think? Is number 9 still one of your weakest topics? Do you feel better? Because I'm also, yep, that's the answer. You round it off to a whole number. All right, question number 10. Question number 10 is vectors, matrices. So I need to know, strong or weak in vectors and matrices? No, quickly. Strong or weak? Okay, I guess strong, in between. In between. Not sure. Haven't studied that topic yet. Week in between. Week. Okay. Yeah. Question number 10, kind of mistake, because some days they just bring basic matrix and vectors, and then other days they would bring like matrix transformations. So I would have taught that, and you just start learning it. Okay. Yes, what's up? Okay, no problem. All right, so let's take a look at this question. So question 1, we understand what the order means, right? Everybody know what's the order of a matrix? The order of a matrix is the arrangement of the numbers. So you have a certain number of rows by a certain number of columns. So the first number is always rows, the second number always columns. So let's look here. What is the order for this first matrix? How many rows we have? 2. How many columns? 2. So this is a 2 by 2. What is the order of the R matrix, everybody? Very good. Also a 2 by 2. 2 rows, 2 columns. What is the order of S? Excellent. It is a 3 by 2 and not a 2 by 3 because it has 3 rows and 2 columns. Excellent. Very good. Now, this question is so easy that people didn't know how to answer it. So let's look and see if you can. Explain why the matrix product QS is not possible. So let's see what QS is. If we multiply Q by S, why is that not possible? There's a rule. For you to multiply 2 matrices, you have to set it out like this. So let's say we want QR, Q times R, right? What's the order for Q? The order for Q is a 2 by 2 times, what's the order for R? The order for R is a 2 by 2. For you to multiply these two, these inner numbers must match. If they don't match, they can't multiply. What does that mean then? When you say those numbers must match, what does this 2 represent? This 2 represents the column of the first matrix Q, and this 2 represents the row of the second column R. Look at it and tell me if you realize what I'm saying. Because remember, the order is always a row by a column. Everybody see that? So they want QS. What is QS? Q times S. What's the order for Q again? 2 by 2 times the order for S. What is the order for S again? 3 by 2. Question everybody, do they match? Do the inner numbers match? Talk to me, do they match? No. So therefore, the columns for the first one, columns for Q is not equal to the number of rows of S. Therefore, they cannot be multiplied. That's just saying the rules. CXC just want to know if you know the rule, you know. Everybody can multiply, but some people don't even know why they're multiplying. So that's the rule. Next one, state the order of the matrix product SR. Now I like that. To find the product, the answer, if you multiply these, the answer gonna have an order of these 2 numbers here. So that means QR gonna have an order of 2 by 2. Let's do a little practice on the side here. So let's say M is a 3 by 4, N is a 2 by 2, P is a 4 by 2. So I'm gonna ask this question. Can I multiply M by N? Everybody tell me. This is a 3 by 4. This is a 2 by 2. Yes or no? This is a no. They don't match. Let's try MP. M is what? 3 by 4. P is a 4 by 2. Yes or no? These numbers match, so it's a yes. So what's the answer going to be? The answer is going to be a 3 by 2. Everybody see that? What about Pn? Can we multiply Pn? P is a 4 by 2. N is a 2 by 2. So these two numbers match, so it's a yes. What's the answer going to be? What's the order of the answer or the product? The answer is going to end up being what? A 4 by 2. Excellent. Guess what? That's it. That is literally it. So let's do this one together then. State the order of the product SR. What is SR? S is SR. We know S is a 3 by 2 times R is a 2 by 2. So somebody tell me the answer. These match, so we know they can multiply. So what's the answer for the order? SR gonna be what? A 3 by 2. Excellent. Very good. Excellent. Now, I have a question. Do you know how to multiply a matrix by yourself? Talk quick, talk quick. These are the basic things, eh? Addition, multiply. If you don't know how to multiply a matrix, you can't do nothing in matrix because almost everything requires multiplication. So let me run it. So they say find QR. So QR, I'm just gonna go through. So all this is revision. You take your Q. I don't know why I use a square bracket. You could use a round bracket. So Q is what? 2, -1, 4, 3. And R is a what? 1, 6, -5, 4. Now I can just show you how I just do this to avoid making mistakes. To multiply, you multiply rows by columns. So the first one is to circle your rows in the first one. Circle your columns in the second one. Mandatory. You do this, you never make a mistake and you could go through confidently. Now, we know that this is a 2 by 2 times a 2 by 2. So what kind of answer I'm gonna get, peoples? What kind of answer will I get? A 2 by 2, excellent. So I am just gonna map out my 2 by 2 space. 2 rows, 2 columns. Now, I'm just gonna label my stuff. This is top row, bottom row. This is left row, let me use red. Top row, bottom row. Left column, right column. All of these have a position. This would be my top left. This is my top right position. This is my bottom left position. This is my bottom right position. So these tell me which two are supposed to be using. So here you're using T and L. So that means you're gonna use row T and L. You multiply the first two and you add it to the product of the second two. So what do I mean by that? There we go. You're just watching, you should know what to do. It's 2 times 1. And I'm doing it the long way. 2 times 1 plus the second 2 is what? -1 times -5. -1 times -5. Let me do the bottom left. So BL, 4 times 1 plus second 2, 3 times -5. Let's do top right. So T and R, 2 times 6 plus the second 2, -1 times 4. Bottom right, D and R, first 2, 4 times 6 times the second 2, 3 times 4. How do you know that you're going right, people? These numbers should match. 1 match with 1, -5 match with -5, 6 match with 6, 4 match with 4. Everybody see that? If those don't match, you make a mistake somewhere, you got to look at it and fix it. All right, this part should be easy, right? So that we run through it quickly. Talk to me if anybody know 2 times 1 is 2, plus -1 times -5 is 5. Bottom 4 times 1 is 4, plus negative 15. 2 times 6 is 12 plus negative 4. 4 times 6 is 24 plus 3 times 4 is 12. So come down, you realize how we just write the answers. We don't go all over the place. We come down. So your first answer is 7. I have a question. What's the answer for this, everybody? Without your calculators, of course. Because we know that a plus and a minus going to change into what? A minus. And 4 minus 15 is negative 11. Excellent. Same thing here. A plus and a minus going to turn into a minus. So 12 minus 4 is 8. And this one easy, 36. Everybody okay with multiplying? If you're good to go, say good to go. All right, let's move on. Next section is un momento, por favor. Right. Okay, let's get here. All right. So given that A is equal to this, and what should you realize here? That instead of having all numbers, you have one of the positions got what? X. Everybody know the positions of these? All of them got a letter. So this would be a this would be a B, this would be a C, this would be a D. Everybody know that, right? For 4x4, 2x2 matrix, those are the letters for those positions. And it's standard, always that. All right. What does this mean? This means something. What I mean? It starts with a D. This is called the determinant. So this would be the first formula that you need to know. How do you find the determinant of any matrix? The determinant of A is equal to A times D minus B times C. Y'all know that, right? And in this question, we know what A, B, C, D is. This is A, this is B, this is C, this is D. And what they're saying is that this has an answer. The answer is 5. So use this to find what X is. So my first question before I do it, do you know how to work this out? Yes or no? This does come a lot, by the way. This question has come a lot. Is yes or no? Do you know what to do? Yes or no? I have 23 people in here and only 3 people answering. Does that mean I should end class then and go have lunch and go relax? Because is that gonna happen, eh? Elena, I know one thing. I could be relaxing right now, and if y'all want us to have class, the agreement is to answer. Okay, that's strike 2. So there we go. So since we don't know how to work this out, you always start with a formula, okay, guys? So this is what you do. This is the formula here, okay? And this is what you should have written in your book. So you're gonna start off by saying that's A. Hold on. Let me just fix myself up. So you're gonna say, you start off with what A means. This means that is equal to AD minus BC. And they tell us this guy answer in it, and that's supposed to be equal to 5. So everybody understand this connection right here? They gave us this part. They say it equal to 5, but we know that it has a formula. So you just gotta put it equal to the formula. Now let's substitute. What is A in this example? 4, right? So you have 4 times D. What is D? D is X minus B. So that's minus B is -1 times -7. And all of that should equal to what? 5. So I hope everybody following us along. So let's go. 4 times X is 4X minus -1 times -7 is +7 is equal to 5. Can you solve this? Everybody solve this, because if you can't solve this, yeah, that's a big problem. Solve that for me, please. And when I say solve, find the value of x. Transpose to find x and tell me what it is. So get rid of the 7, get rid of the 4, tell me what you get. That's one person. And I'm telling you no, if you cannot transpose this linear equation, you are going to, that's not a good sign. So I'm going to start. If I want to find x, I'm going to get rid of -7 first. When I move it over, it's going to become the opposite. So you're going to end up with 4. X is equal to 5 plus 7, which is 4. X is equal to 12. And to get rid of the 4, you divide by 4 on both sides. So x is equal to 3. That's the answer. Yeah. Simple. That's it. Moving on. That was vectors. Woo, that was easy. It was very easy. Very, very easy. All right. So let's answer the last part. Vectors. God give us strength. Let me see. What are the rest of the questions for vectors though? Mm. So let me use this version here then. No, everybody understand how vectors work? So let's go through this question because a lot of questions just come like this, okay? So let's read what they gave us. In the diagram, OPQ is a triangle. Look for OPQ. OPQ is a triangle. ARB and AOQ are straight lines. So ARB is a straight line. AOQ is a straight line. Everybody seen it? So you understand what information they give you? All right. No, they tell us that, let me go back to the original diagram just to see something. You realize they didn't give us no arrows? Everybody realize that, right? So we need to pay attention to what this information is going to give us. So they say B is the midpoint of PQ. That means PQ, where's PQ? Look for P. PQ is a vector. So that means the direction of this vector is going this way. Everybody agree? That's the way PQ going because they tell us B is the midpoint of PQ. So you're putting your arrow. So that's the direction of the vector, PQ. I only put 2 so that you know that it's split in half. It makes sense, right? Because what did they say? B is the midpoint. So PQ gets split in half. So that's 2 vectors there. Everybody following? Because they don't give that. You have to put this information in yourself. R is the midpoint of AB. That means AB is another vector, right or wrong? So that means this is another vector here. And that means that these 2 are equal. So this is equal to that. AB, AR is equal to RB. Everybody with me again? So we got 2 lines cut in half. No, look at what they tell us here now. OR and RP is broken down into a ratio 1:3. So let's look at OR. That means that this part is 1. That's 1 part, right? And that's a vector as well. And RP has 3 parts. So that means I got to break up RP into 3 parts, right or wrong? Everybody see that? So how many pieces does OP have in all? OP has how much parts in all? A 4. Good. Everybody understand that? Because that's the, if you ain't understand that, we can't nothing else. No, this is time for us to label the information. Look at this now. They tell us that OP got 4 A's. How many pieces does OP got? A? 4. That A mean from here to here is A. And from here to here is A. And from here to here is A. And from here to here is A. That's why the whole entire thing will give us how much A's? 4 A's. If you got it, say got it. I love it. Let's go. So next one now. OQ. Well, let's look for OQ. OQ is 8b. So you can go from here to here is 8b. Yeah? You realize it's a little tricky now, right? Everybody see how tricky we get now? No, let's use the information we got. We're going to take it nice and slow. They say, using A and B only in the simplest terms, find PQ. So that means we need to go from P to Q. Did they give us any letters to go from P to Q? No. So guess which way we got to go? We ain't got to go the opposite way. Talk to me. So follow the journey. I could go from P to O, and then from O to Q. Is that possible? So what formula that is now? Let's look. P-O. Let me see who could figure it out. If OP is 4A, going the opposite direction, A is supposed to be negative. Talk to me. So if OP is equal to 4A, that's what they tell us, isn't it? So PO is supposed to be the negative 4A. Let me know if you understand, if you're with me. That's vectors, eh? If in one direction is positive, the opposite direction is negative. Everybody following me so far? Hello? Can you hear me? Yeah, I don't know what happened just now. It just had a little glitch. So I'm gonna share again and we're gonna go right back into it, okay? All right. Thank you for your patience. Thank you for staying. We got this. I'm hungry. What y'all eat for lunch? Nobody ain't even offer me a little pumpkin fritter, nothing, no orange juice. What's going on? Where were we, guys? You got orange and grapes? I like orange and grapes. Okay. All right, so let's get back here. So let me just ask quickly, everybody understand the point I'm making? If you going forward, forward is positive, backwards is negative, right? So if I want to go O to P, that's a positive 4A. So to go backwards, P to O, that's negative 4A. If you got it, say got it. I just want to make sure you understand. Okay, so that means PQ, let's follow the path. How do I go from P to Q? I had to go from P to O first. Then I go from O to Q. That ain't true. Look at it. PO plus OQ. Everybody seeing that? So let's go. What was PO? PO is negative 4A plus, what is OQ? What is OQ? In 8B, they ain't give us that. Look at here, OQ is 8B plus 8B. Now here's the trick. You know, they ain't gonna like it like this. They ain't like it when they look like this. You always got to factorize. So let me show you what I mean by that. Switch these around. When you switch them around, it's gonna become 8B minus 4A. Makes sense, innit? It look better like this, innit? Then, do they have anything in common? What they got in common? 4. So you can factor out 4. When I factor out 4, I'm gonna get 2B minus A. That's your answer. Hello, y'all with me? Look at right here. Now look at what CXC do here. This ain't look like a bunch of drama, be honest with me. Look at this. Why would it teach anybody to do it this way? So which way you prefer? The simple way, right? Just follow the steps. I find this is so unnecessary. So let me zoom out. For those who are advanced, you could probably copy down both if you want. So, yeah. So everybody see how we got the formula? We just look at the steps and add up and go accordingly. Now we're going to do the second one. They ask us to find PR. How to get to PR. This easy. Anybody could tell me how to get, oh Lord, they got the answer there, but I want you to try without using the answer. How to go from P to R? Somebody, talk to me. Look where R is. This is R. Let me highlight R. Watch where R is. And this is P. How to go from P to R? Aim backwards. So would it be positive or negative? Remember, this way is positive. This way is positive. So to go the opposite way, it's going to be what? Minus 3A. How much A's you need to get to RA? 3 of them. Look at here. Negative 3A. That's it. That's the answer. Now, let's find RB. Where's R and where's B? Anybody think they could know how to find RB? Let's erase all of this drama here. How to find RB? Where we gotta go? Let's do a formula. Let's do a pathway. Let's do a pathway, right? To get RB, let's do the formula. RB is equal to what? In RP plus PB. Talk to me. RB, RP plus B, PB. So let's start with that. Do we agree with this part here? The pathway, we just choose the pathway. We're gonna go from R to P and then P to B. Everybody okay with that? No, this is supposed to be an R, guys. Lord help me. How do we go from R to P? We ain't just find the answer just now. We ain't get RP. How do we get RP? RP is going in the right direction. So RP is just 3A plus, how do I get BP? PB, sorry. What do we know about PB? PB in half of PQ. Hello? PB in half of PQ. Don't we know what PQ is already? We don't know what PQ is already. Look at here. 3A plus half of PQ. Right or wrong? And we know that PQ, we found it before, where the formula is, where it is, where you gone? Remember, we didn't find it. Look at here. 4, so it's half of this. Talk to me. Yeah? Everybody with me? So all we gotta do is know, this is the part, no, this is the maths part. Half of everything, if you're halving something, you ain't gotta have both elements. So half of negative 4A is negative 2A, agree, right? And half of 8B is 4B, right or wrong? And then when you reach here, you know, algebra says to do what? You must add and subtract your like terms. So that's how you end up with 3A minus 2A is just 1A. And you know, we don't put the 1 in front. It's understood to be just A plus the 4B. And that's it. You won't believe that's it, guys. That's for vectors. That's vectors there. That's how most of the vectors questions has come. All right, so we're gonna do, let's see what time it is. We got half an hour. Let's see if we could push in 2 more. But everybody was able to follow the first question. This was 2023 of this year. Let's go into June 2020. I am going to look at the questions up here first before we answer. No, I'm gonna tell you no. I taught my class transformation, but we only did it, like, you know, we need some more practice. Did anybody learn matrix transformation, the calculation method? Yes or no? No? I need people to talk to me, talk to me, talk to me. It's not that hard, to be honest. Once you know what to do, we're gonna go through it now. So those who never learn it, you're gonna learn it now. And even if you're not 100% perfect, you're not gonna lose a lot of marks. Because for example, look at the marks they give. It's just 1 mark, 2 marks. Yeah, so no worries, guys. I got you. I got you. I got you. So let's look at the first one, okay? Anytime they ask you to do a matrix transformation, guys, it really only requires you to multiply, okay? So they're going to give you something. They say the transformation matrix A. So this is the transformation matrix, and this is what it does. When you multiply this to any matrix, it's going to rotate it to anti-clockwise. Anybody know what anti-clockwise mean? So if the shape is here, the shape going to end up over here. That's what anti-clockwise mean. Because clockwise mean this way. Okay? I just need everybody to say yes or no. Got it. If you got it, what anti-clockwise mean? Luckily for us, this just means calculation, so you don't have to worry. Once you know how to multiply, you're good to go. All right? The next one, they give us another one. They say the transformation matrix B. So this is the first one and this is the second one. You realize they look similar, but they're not. Look at the difference. Sorry about that. The first one got -1 and +1. The second one got -1 and -1. So two of them are going to do two different things. This means that you're going to have a reflection in a straight line equation in this axis. If you don't know what this means, don't panic. I'm going to go over this at some point. So you don't even got to worry about that. So it says here, write the coordinates of P prime. This is what happens to the shape after you add on the matrix or multiply by the matrix. Okay? And it says the image of the point P71 after it undergoes a rotation anti-clockwise about the origin. So which one you think you got to use, the A or the B? Look at what they said they want you to do. Undergo a rotation by 90 degrees anti-clockwise. Which one should we use? Even if you never learn this, you must be able to read and tell me if it's A or B. Which one should we multiply by? I need everybody to answer, because it's just a reading thing. Let's go. Talk to me. Thank you. Anybody else trying? They gave us two transformations. One is A, one is B. Which one do you think we need to use? It says a rotation. Which one talks about a rotation? Only A. Now, this is the thing you got to remember, everybody. P prime is the image. This is what happens after you do the transformation. Is equal to AP. What does AP mean? AP means A times P. Everybody with me? So all you got to do is multiply A to P and that's it. You always put the transformation first and you put the matrix after. That's the formula. So you see this formula here? You need to know this formula here. So there we go. We know how to multiply matrix. That's easy for us. So let's go and see if it could be multiplied. What is A? Let me use black. What is A? A is simply 0 minus 1, 1, 0. What is P? They gave us P. They gave us P as a point. But how do we write a point as a matrix? You just write it X above, Y below. So who should go to the top, everybody? 7, very good. And who should go to the bottom? 11. So let's stop right here. Everybody with me until this point? So for us to find the answer, which is P prime, all you got to do is multiply the transformation to the matrix they gave you. Do we know how to multiply? Yes, we do. We multiply rows by columns. People, can these two be multiplied? This is a 2 by 2. This is a 2 by 1. Yes or no? Can I multiply these two? So what is my answer going to be? My answer is going to be a 2 by 1. So that means all I need is 2 rows and 1 column. So let's go. You got the top and the bottom. So let's do the answer for the top. The answer for the top is going to be 0 times 7 plus -1 times 11. Let's do the bottom. First two, 1 times 7 plus 0 times 11. So what's my final answer? 0 times 7 is 0 plus, so you're going to be -11. And what's going to be at the bottom? 7. Guess what? That's it. Everybody see that? So they didn't ask us to leave it like that. They asked us for the coordinates. So you see how the points there, we just got to rewrite this back like that. So if P is this, that means P prime is equal to negative 11, 7. So that's your answer. Literally, guys, that's it. Do not stress yourself. Matrix transformation is just multiplying by matrices. Okay? So let's do the second one. T is the combined transformation of A followed by B. So if A is the first one, right? So it's a find the transformation T. So they say combine. That means you're doing a matrix, a transformation after a transformation. Who they say come first? Which one come first, the A or the B? This is for everybody. Let we go. Especially if you never learned this, I want you to try. Which transformation comes first? If they tell you A followed by B, who comes first? A comes first, right? So if you multiply by A first and then B after, where should the B go? Would it be BA or AB? Everybody pick one. Which one would it be? Unfortunately, everybody wrong. Yeah, forget where you're supposed to apply a transformation. Means that the transformation must always go in front. So if you start off with transformation A and you add another transformation, where it got to go? It got to go to the front, to the front. Don't get trapped. That's a trap. Everybody see what I mean? So let's say I got transformation A, B, C. How do I apply this? How does the combination go? If A come first, where should I put the B? If B comes second, B gonna go here. Where should I add the C? C come last. C come here. Everybody see what I'm saying? Got it? All right. So let's find BA. How do we find BA? We got to multiply B and A. And we know what B is. What is B? Let's go up here. What's B? B is 0, -1, -1, 0. What is A? A is 0, -1, 1, 0. Yep. So just for time, I'm just going to scroll along so you can see the answer. Look at here. See? T is BA. See the same thing? 2 by 2, so they could multiply. You multiply out, this is the answer you're going to get. And that's your answer. You realize what I tell y'all about multiplying? You need to know how to multiply because you do a lot of it. So that's the answer. Don't worry about how they break down their multiplication steps. You do your multiplication how you know how to do it. Do it how you do it, your rows by your columns, and you find your answer. Everybody see that? Hello? No, it says describe geometrically the transformation represented by T. What does that mean? When you think about transformation, there's 3 types of transformations. You're either being rotated by an angle, reflected in a mirror line, or you're being translated, which means you're either sliding up, down, left, right. And the last one is enlargement. I hope y'all learned transformations already, basic transformations. Y'all know what I'm talking about, right? Please let me know and tell me the truth. Do you know what I mean when I speak about rotation, reflection, translation, enlargement? Okay, good. All right, so that's it. All I want to know is when you don't do all them things, what happened to the shape? Did it rotate, reflect, translate, enlarge? So we're just going to read it here. It says T is a reflection in the y-axis. Because this is what this transformation means. It's a reflection in the x-axis, sorry, not the y. Apologies. All right, so that's it for that part. Now we could go into some more simple stuff. The matrix C is defined as a scalar constant. So you realize the same thing what we did before. There is a letter here instead of a number. Determine the value of K given that the matrix is singular. Now this means something. What singular mean? If the determinant of the matrix is 0, therefore it is singular. So yeah, remember what we did for the previous question is the same thing. So what is the formula for C, the determinant of C? So the determinant of C is AD minus BC. And instead of equal to 5, you see the last question, it was equal to 5, and look it down here. Here they tell us it's equal to 5. Here it's equal to 0 because it's singular. So equal to 0. Let's do the same thing. What is A, everybody? That's a serious question now. What is A given this information? And I'm not writing until I see people tell me. So that's one person, Simone. Thank you. I'm waiting for everybody else to try. What is the A? Okay, that's 2 more. 3. Okay, excellent. So that's A, very good. 3 times D. What is D? Very good. Anybody else? What is D? Yeah, we got a few more minutes before we end the morning session. Let's go. Excellent. 4 minus B. What is B in this case? Excellent. K, right? Very good. Times C. What is C? 6. And your answer is equal to what? 0. You all should know what to do from here, no? 3 times 4 is 12. Minus K times 6 is 6K. Solve this for me, please. Tell me what the answer is. Find K. Some people say 6, some people say 2. Talk to me. What is it? So let's do it. No, I'm gonna be honest with you. You got 2 ways you could do this. The smart way is to just move the minus 6K over, so it could become positive. So you will get 12 is equal to 6K, or 6K is equal to 12 divided by 6 on both sides. So K is equal to 2. Or you could do it the regular way. 12 minus 6K is equal to 0. When you move over 12, you're gonna get negative 6K is equal to negative 12. You divide by negative 6 on both sides. So you get K is equal to plus, because a negative and a negative cancel each other. So you get K is equal to 2. Excellent job. Excellent job. So let's do our vectors now. See, K is equal to 2. Let's look into our vectors part now, and then we're gonna take a break for our afternoon session. All right, so let's look at this here. Let's take a look at this here. It says here in the diagram, 0 is the origin, right? So once it's the origin, you know you're dealing with position vectors. I hope y'all know that. So O represents O, origin. You should know displacement vectors and displacement and position vectors. So let's look at what they have, guys. They say OX is equal to U. So you see in this question, y'all see the difference? What's the difference between this question and this question? Here, did they give us the arrows? No. This is the hardest question that could come. When they don't give you the arrows and you got to do all of this by yourself. So honestly, this question is very easy. Everybody see what I'm showing you? Because they gave us the information already. OX is equal to U. You realize they give us OX is equal to U. Boom. OY is equal to V. Look at that. OY is equal to V. Now look at this. OX and OY are extended so that they are midpoints of OA and OB. What does that mean? What can I label here then? This could also be labeled what? Excellent, U. Because if this is the midpoint, I mean, if this is U, up here is U as well. Same thing here. What do I label down here? Excellent, V. So that means the whole line OB is 2V. The whole line OA is what? 2U. I hope you are seeing that, right? Yeah? Okay. Let's look at the first question. Express BX in terms of UV. They want to go from B to X. Let's write we pathway. How do I get from B to X? Somebody talk to me. Where should I go first? B to O. Everybody seen it? B to O, and then from O to who? OX. Do we agree? Look at the pathway. You go from B to O, and then from O to X. No. Look at this now. What is the formula for BO? Look at the direction of the arrows now. If OB is positive 2V, what is BO? I'm waiting to see people to try. Liar, you're killing it. What about everybody else? Come on, talk to me. Do you agree that is negative 2V? Because if from O to B is 2 V's, you realize it's 2 V's, but when you want to go from O to B, you want to go from B to O. So that's the opposite direction. So that would give me negative 2V plus what? How do I go from O to X? Plus U. Guess what? That's your answer. Can we write this in a different way? Yes, you can use it as U minus 2V. I would recommend you write both ways for CXC. And everybody understand how we get this, right? All we did was switch them. If you got it, say got it. After this question, we're done, guys. So just make sure you follow along. All right, so that's the question here. Let's see, everybody see that? That's how it is, blah, blah, blah. Look at that, you see? And you realize how they prefer it. I hope y'all looking and seeing how they prefer it, right? They like when you switch it around, okay? All right, next one. Given that YA, where's Y? Y, okay, we see Y and we see A. So they're saying, given that YA and BX, where's BX? So guess what? You know, in the exam, you have to draw it, right? You know that. So in the exam, you get a pencil. They say YA. And point in the direction, they say YA. And what was the other one they said? BX. BX intersect that M. So connect BX. Where's BX? BX. This arrow this way. And they say they intersect at M. So you have to label here. And you have to put your M. Because, you know, intersect means where they cross each other. So let me pause here. Everybody see how I got this diagram? All I did was do what they tell me to do. They say YA and BX intersect at M. Yeah? And what other piece of information they give us? This says that and BM, where's BM? BM is equal to 2mx. So if that means BM is 2mx, what does that mean? That mean that here to here is 3 spaces. That these spaces here equal. Everybody see what I'm showing you? They're saying 2 of these equal 1 of these. Hello, y'all with me? You realize? Yeah? So this is what you should have, right? So let's look at the next part now. So we all here, we all agree with this part. They say express BM in terms of U and V. BM. So that means they want you to go from here to here. How can I get BM if I don't have BX? So what do you think I got to find first? BX. But don't we have BX already? Right or wrong? Because BM is 2 out of 3. Look at here. BM is 2mx, which is 2 out of 3 of BX in 2/3 of the line. And we done got BX already. So it's just 2/3 of this. So all CXC expect you to do, to be honest, if you leave it like this, you will get your mark, but they just want you to expand the brackets. So you say 2/3 of U is 2/3 U minus 2/3 of 2V, 2 times 2 is 4. That's how they get is 4. And you put it over 3. Yeah, I realize everything we used before it just coming back together. So that's it. So the last question now, using a vector method, show that the ratio YM and YA is 1 to 3. Where is YM? YM is 1/3 of YA. You realize that's what it say, right? So let's do that. How do you find YM? YM. YM, how do you get from Y to M? You got to go to B first, innit? So YM, write your pathway. What's your pathway? Equals to YB plus BM. Oh, you're following me? So you see the pathway you got to follow? So don't we have YB already? How do we got YB? We ain't got YB, we ain't know what YB is. YB in another V. They ain't give us that in the beginning. Talk to me. Look at here, B is V and BM. What is BM? BM, we didn't find that just now. What did we find just now? Yeah. Look, BM here, we ain't done find BM. So you take BM, which is this formula here, and you add them. No, this is the part. What is hard? It ain't really hard, but it's just fractions. So if you leave it like this, let's say you're running out of time. If you leave this, if this is 2 marks, you will get 1.5 marks, 1 mark. So what they're asking you to do is to group your like terms. So this is V plus 2 over 3U minus 4 over 3. I want you to get your calculators because your calculators is what going to save you. So this is where you're putting your calculators. 2UV is a unlike term, so nothing gonna happen to 2UV. But what is gonna change is that V plus 4 minus, sorry. So let's rewrite this. So you have 2 over 3U plus V minus 4 over 3V. So let's make sure we understand how I got that. All I did was rearrange it. I put the U by itself and I grouped the two like terms, which is the V minus the V over 3. Everybody following that part? Now, this is the trick. Use your calculator. V by itself ain't 1V. So put this in your calculator for me. So this part ain't changing. 2 over 3 ain't changing. So put in your calculator 1 minus 4 over 3. You should see the fraction function. So you put 1 minus 4 over 3. It should look like an L. So you put in your calculator 1 minus 4. You can see the little L thing, 3. Everybody see what I mean on your calculator? When you do the fraction thingy, and you should get minus 1/3. That's your answer, minus 1/3 V. You see what you get is? Don't work hard, work smart. Use your calculators to deal with this addition and subtraction of the fractions. And just to explain how they got this part, this is 2/3 and this is 1/3. I could get 1/3 from both sides. So if I pull out 1/3, what is going to be left back? 2, because I pull out, it's 2/3 I have. And if I pull out the thirds, you're going to left back with 2U minus, if you pull out the whole third, you just left back with a V. That's how you get that. Boom, that's it. And the last part is to find YA. The same thing, you follow the formula. YA, how do I get to YA? You got to go back to O, Y to O, and O to A. And you know, this is U. So that is just minus V plus 2U. Look at there, minus V plus 2U, that's it. All right, so just stop in here because that's the end. Everybody was able to follow along. So we're gonna take a break here. How much exams did we do for the vectors? I think we only did 3, we did 2 or 3. When we come back this afternoon, we're going to do one more, the vectors. And let me just tell you which questions we're doing this afternoon. We're doing the questions that everybody hates. So the questions that everybody does hate is question number 3, question number 6, and question number 8. Because all of the other questions I sent you all YouTube videos for already, so you can look at those videos to help you. So we're going to focus on the harder questions. So see you this afternoon at 2 o'clock. Bye.